So, like I said, right, we are going to start with PROC SQL. It is one of the base SAS procedure. Is one of the base SAS procedure, right? So, like I said again, okay, you have to be very clear before you learn PROC SQL or procedure SQL. As you already know, so we are basically procedure structure language. Okay. So SQL basically stands for structure query language. Query language. Okay. You must have heard of SQL outside SAS, right? I mean, SQL is one of the mostly used, right? The query language, which has the SQL servers, databases, database management systems, and everything, right? So Oracle SQL, Teradata SQL, so everywhere SQL is used, okay, especially when it comes to databases. So in SAS, again, it is going to be quite easy because we already learned data step. So we are going to compare and learn data step and SQL so that it will be a lot easier for us. So we don't have to again talk the new concepts here. Okay, so the methodology that we already learned in data step is going to remain same. The PROC SQL, all we are going to do is we are going to learn new type of query language. Basically, it is a query language. Okay, again, you would understand why we are calling it a query language. Okay, so PROC SQL basically it updates, retrieves, modifies tables or databases. Okay, so again, we can perform querying from databases. We can use PROC SQL to query data from databases. Okay, so extract data from databases, manipulate, process the data. Okay, process the data. So pretty much what we did in SQL. Okay, I mean data step. So again, like I said, right? So you're not going to learn any new methodology here. Methodology wise, you already learned everything in data step. Okay. So PROC SQL just takes the capacity of SQL, the SQL general SQL. Okay, so so we have to remember we are going to call it SAS SQL. So it has SQL components, general SQL components, which we are going to use. Okay, so for our convenience, we always can prefer SAS SQL because it is built in SAS and it uses the SQL components. Okay. The reason SAS started leveraging SQL capacity is in SAS is so in data step. Again, we are going to compare data step with SQL, right? So there will be cases where PROC SQL requires less amount of statements and easy to implement or write queries classes. Okay, so time to time again, you would find scenarios where you would find writing PROC SQL a lot easier compared to data step. Okay, and there would be cases where data step is efficient and you might feel okay, SQL is not that efficient. Okay, so that's the mindset you need to have. Again, there is no rule that you should only write something in data step or you should only write something in PROC SQL. Okay, again, we'll also look at cases where data step is more efficient or easy to build or easy to write the scripts. And there would be cases where you might find PROC SQL is a lot easier compared to data step. Okay, but overall, in real time, both the methods are used, both data step and PROC SQL. But there are cases where you must use PROC SQL and there will be cases where you must use data step. Okay, so some of the components that we learned in data step. So the best example would be we learn arrays, right? So arrays you cannot use in data step. Arrays we cannot use them in SQL. Okay, because SQL is just a query language. Okay, it's not a programming language, it's a query language. Okay, so where The definition of query stands for basically where you extract the data from databases and you update or retrieve or modify the tables or tables from databases. Okay, so generally even SAS SQL, the SQL components are 3 types. Okay, so when I say components, again, it is not related to SAS in general terms. Okay, outside SAS. Okay, so there are 3 components: DDL, DML, and DCL. Okay, so DDL stands for Data Definition Language. DML stands for Data Manipulation Language, and DCL stands for Data Control Language. Okay, so these are the components are usually available in SQL. Okay, so when it comes to SAS, we do not have data control language because we are just using it for the data manipulation. Okay, so just like data step. Okay, in data step also basically so this data control language, again, you'll know in a bit. So basically we are going to focus on these 2 components. Okay, so these components are basically used to, our users are to update the tables, to update, to create, to modify tables. Okay, so when I say table, basically in SAS, it is a data set. As long as you're using PROC SQL or Procedures SQL, in SAS, we are still going to call it a data set. But the SQL terminology will be a little different. The PROC SQL terminology is a little different compared to what you learned so far. So the rows are called observations, columns. So basically, in SQL, we're going to call them rows. The observations are called rows. In SAS, we are basically calling them observations, right? So in SQL, again, we call them columns. In SAS, basically, they are variables. Okay, so we call the 2-dimensional structure that we learned a data set in SAS. Basically, in SQL, we're going to call them a table. Okay, wait a second. Somebody pinged. No, Tony, we just started. Okay, so yeah, so this is the terminology. Okay, again, we need to get used to this terminology. Again, you will know in a bit again. Okay, when we start writing queries, it will be very clear why this terminology. Okay, again, there is no rule that you should always call them. Okay, because everything is in SAS. It doesn't matter what you call them. You can either call them observations. Observations are rows, or you can call them columns or variables, or you can call them data sets. So since every one of us have been used to the data step at the beginning, so you might always find it comfortable calling observations rather rows, columns rather variables. Okay, again, there's no issue. You can call them anything. Okay, I'm just talking about how SAS describes this. Okay, so that's the terminology. So again, let's go back to the SQL components that we are going to focus. Okay, so these are the 3 components that are available in SQL. Okay, not just in SAS, even in general. If you want to learn MySQL or SQL, any of the SQL, okay, regular structured query language, right? So these 3 you always learn. Okay, so let's see what do you mean by DDL and what do you mean by data man. So again, it's a pretty simple concept. Again, you don't even have to remember it, but again, since you are learning it, it's always better to have this knowledge. Okay, so let's just go back. So when I say data definition language, these are basically used to describe the data. Okay, so the name itself suggests, right, data definition language. Okay, so this data definition language consists of certain statements. Again, these are the statements. Okay, just like what we learned in SAS. So create and select. Create, I missed it. So alter and drop. Okay, so these are the statements. Okay, create, alter, and drop. Okay, these are actually we call them queries. But again, in SAS you can simply call them statements. Okay, we call them queries, or you can call them commands. So we also call them classes. Okay, but as long as you are in SAS, you can always call them a create statement, an alter statement, and a drop statement. Okay, again, there is no nothing wrong in it. Okay, so again, you just remember these three commands: create, alter, and drop. When we get to this, again, we'll understand. Okay, these are quite easier because you already have seen them. Again, you will know in a bit, right? So again, the data manipulation language, this particular component has a few more commands that we have to learn. Okay, not just in SAS. Again, you have to remember this is not just restricted to SAS. Okay, and another thing you have to remember, whatever the SQL knowledge you are going to gain here, in terms of programming, it is the same everywhere. Okay, in future, if you want to work on Teradata, so Teradata basically is a SQL component, has SQL components, and all you have to do is you have to use them there. So even Oracle SQL, Sybase SQL, any database, right? Any relational database management system which have SQL, which are built on SQL, basically you can use them anywhere. So you have to see that, you have to understand that you are not learning these SQL component just for SAS. You can always use them outside SAS also. But of course, there will be minor differences because the entire SQL functionality is not built in SAS. Okay, so only what is required is built. Okay, but yeah, so 70 to 80% what you learn here can be easily used outside without having to learn that particular tool. Okay, let's say you joined the organization and they ask you to work on Oracle, and Oracle SQL basically is used. All the components what you are going to learn, you do not have to go back and learn it. Okay, so the majority of the stuff you are going to already learn here. So yeah, that's the bright side. Okay, so that's why people tend to write a lot of SQL queries in real time. Okay, in the data manipulation language, so these are the statements. Okay, select are commands we are going to learn. Okay, select, insert, update, and delete. Okay, so these are the statements, the commands that you are going to learn. Okay, so so again, there will be more classes that you are going to learn, but these are the main statements. Okay, 3 statements and 4 statements. Again, I'm telling you, you do not have to remember them. Okay, I'm just giving you basic knowledge here. So the reason I said the data control language or DCL, right? We do not have this facility in SAS because these are basically granting. So these are basically, you can think of it as admin, system admin roles, right? Where you can allow users to use your particular database. So that's why we do not have it in SAS, because SAS is not a database, and you do not control what tables are being accessed by someone. Okay, so that's why we do not have this data control language. So I'm just going to remove it. Let me put it here so that. So the data control language, let me put here so that you would understand. Okay. Yeah, so we are going to focus on this DDL and data definition language and data control language. Okay, and so this is what we're going to learn. So we are going to learn how to manipulate the data and how to process the data. Right. So first, let's start with a very basic one. Again, like I said, creating data sets in data step versus PROC SQL. Okay, so this is the first thing. If you remember, in data step we learned, okay, where we talked about how to create a data set. Okay, so this is how we create a data set, right? For example, I just want to create a data set. We all remember this: input, ID, age. Let's assume I just want to create it this way. Can I run this way? No, right? So it says that no data lines are statement. Okay, or else. So let's say I just give data lines. Okay. Now what happened? You are able to create a data set without any observations. You created a data set. You know that you can pass this observations here. For now, what I did, I just created an empty data set. I just created an empty data set. So if I go into my work library, again, we are just looking at the basics now in order to understand. Okay, so see, an empty table is created with 0 records. Data set has 0 observations, and 2 columns are there. Okay, 2 variables are there. So let's see, how do we do the similar thing in SQL 2? Okay, so when it comes to syntax, right, SQL follows a different approach just like data step, SQL start with PROC SQL and immediately have to end it with SQL. Okay, so PROC SQL semicolon. Unlike data step, you have to start it here, and you have other classes or statements just like in data step, and you always end it with a quit statement. Okay, so data step starts with data, and then PROC SQL starts with data. PROC SQL starts with PROC SQL. So this is right. So in data step, these are the program step boundaries. It starts with data and ends with run. In PROC SQL, it starts with PROC SQL and it starts with quit. So again, we learned the difference between run and quit sometime back. So run is basically implicit processing, implicit running processing. So what does it mean is you cannot pass multiple steps inside this one. Okay, multiple data steps inside this data step. Okay, it will always have to be one. Once you open data and before n, what are the statements? You can only execute the statements. You cannot process multiple steps in here. Okay, it is always considered as one step. So whereas in PROC SQL, which is the quit is known as explicit processing. If you remember, PROC data sets will learn to use multiple procedures inside it, right? So the similar thing is going to happen. Okay, so you can process multiple steps inside one PROC SQL statement. Okay, so that's again we'll look at it, right? So this is a very basic one, right? So now let's go back here. So I just created an empty data set here, okay, without any observations. Okay, let's see how do we do it in SQL. Okay, so in SQL again, it always starts with PROC SQL. So the first statement you are going to learn is the create table, which we learned in the data definition language. Okay, so basically just like data here, which is defining the data set name. So we all know what does data do here. It's a data keyword or a statement basically creates a data set. So here create table does the same thing, which is used to create a data set. Okay, so I'm just going to create new one. Okay, so this one data new and create table new one, both are same. Okay, basically you are defining a data set name in both the cases. Now you used input statement here, right? You used input statement here to create the columns, right? In SQL, there is no input statement. All you have to do is you have to open braces and you have to create the variable names. Okay, you have to just give the variables. So that's it. So these two statements, data and input, are clubbed into one. Okay, again, they are not clubbed. For your understanding, I'm saying that they are clubbed because SQL is it's a one query language. Okay, it doesn't depend on SAS. So for you, when you try to understand, you defined the data set name and column names in two different statements here. When it comes to SQL, you defined everything in one. Okay, so this has one part and everything in braces, you can consider them as input statement. Okay, so let's just run it. So here also I'm not creating any observation. I just created a table here. Run it. So go look at the log. See here, it says the table work dot new one created with 0 rows and 2 columns. So look at the terminology here. It says table created with rows and columns. Unlike in data step where it says observations and variables and a data set, here the terminology is different. But if you look here, both the outputs are same. Okay. Only thing is the syntaxes are different here. Here again, there is no data line statement. So here we pass data lines and we just kept it at blank, right? Now, this is just creating empty data set. Okay, so now let's pass the observations, for example. So here in SAS, again in SQL, basically when you defined a variable here in data step, we do not have to specify anything for numeric variable. Okay, if you do not specify $, by default SAS assumes that these are the numeric variables. Whereas in SQL, you have to define saying that this is a numeric variable. All you have to do is just write NUM. NUM stands for numeric. Now, let's say you have a character variable in data step. So what do? You define with a $, right? So whereas in SQL, you have to write char. Okay, so basically you are trying to build a character variable. And another thing, if you observe, when you define variable names here in SAS, you do not have to it is just separated by a space here. When it comes to SAS, they are separated by comma. Okay, each column has to be separated by comma. So this is something again you have to remember. In SQL, every variable has to be separated by a comma. Okay, because in SAS, whenever you lend, you did not so that's the rule, right? In SAS, basically it understands by space. Here you have to put a semicolon. Sorry, a comma. Now let's just run it. So if you go here, you have ID, age, name. So I'm going to run the same thing here. So it also has ID, age, and name. So this is how you create a SQL data set. Okay, so this is the syntax. Now let's pass some observations. Okay, so let's pass some observations here. So first data step. Okay, so here you would go right, let's say 1, 2, 3, 27, name is Mark, 1, 2, 4, 28, John. Okay, so if you run it, a data set is created with ID, age, and name. The same way in SQL, if I want to create, right? Now, just like data line statement, in SQL, we have a statement called insert into. So this insert into will insert the columns into the data set. So all you have to do is insert into, write the table name, and then you have to specify a statement called values. Insert into new one and values. Okay, this is the statement. Again, you are learning a new statement, and then the data set name and values. Okay, open braces. Then you have to define column, the values, observation values separated by commas. Okay, so this is for the entire record. Okay, so this is similar to this one. So instead of data line statement, here you are using an insert into and the data set name and values, and you just wrote it. Okay, so one observation per record. So same like here, one observation. So if you want to insert another one, again you have to go and write insert into this particular data set table. I want the values that I want is 1 to 4, 28, and John. Okay, let's just compare these queries. Okay, let me run it. So as expected, you'll have two observations here, and when I go here and run it, it'll also have two observations. Oops, sorry, did I do something wrong? I forgot to check the log. Oh, sorry. So yeah, so you specified the values, right? Again, in SQL, the data values have to go into quotes. Okay, that's the error, because you are in SQL. This is okay. In data set, again, you do not have to specify any columns there, so you just have to specify the values here in quotations. Now, if you go, it must have created. Oops. Oh, sorry. Here I specified new to. So see here, there was no new to data set, so it failed. So again, I'm gonna go here, run it. Now you see the data is being read. Okay, so the outputs are same. So this is a very, very simple method, right? How we create it in a data step and how we create it in a SQL. So let's look at, okay, how do we add dates, right? So in dates, basically, let's say I have employee input ID, you have joining date. I'm just going to call it JDate. Cards are data lines 1, 2, 3, 13, 05, 2018, 1, 2, 4, 14, 5, 2018. So you would write in format and format. We all remember them, DDM and YY. So this is an in format, and you can go write format. Okay, so this is how we create it. We all know it works, right? So the similar way, let's see how we write it in PROC SQL. Okay, so PROC SQL you would write. So first, let's learn to create table, give the table name. So I'm just going to call it EMP1, open braces. First ID, it's a numeric variable. Then we have JDate, which is a date, right? So all you have to do is, so just specify numeric here. You don't do anything, okay? So just specify numeric. Now, insert into, you have to pay little attention here. EMP1, again, I'm just going to pass the values. The first is 123. Then I'm going to write 13, 5, 2018. Okay, so that's one thing, one observation. So next, insert into EMP1, 1, 2, 4. Now let's first run this one and look at our output. So emp, this is our table. Oops, did I do something? Oh, sorry, I misspelled the format here. DDMM YY. I just mentioned only one M there. Now it must have worked. Okay, so this is the output, right? So typically you expect the same thing here too. Now run it. Look at the log. Oops. What did I do? Anything you see here? 1, 2, 3. What happened? Oh, sorry. I forgot to specify values here. I forgot to specify values here, right? Now let's go here. Again, there seems to be an error. Oh, okay. So yeah. So again, it produced the error, right? The problem being when you're defining the date values here in SQL, it would not understand. Okay. So if you specify character, it would understand, but for date, it does not by default understand. Okay. So that's when you basically have to go here and specify it as a date constant. Okay, so 13 Jan, let's say 2018. So we all know what is a date constant, right? So that's how SAS accepts it. Okay, this is one problem in SQL. Okay, so now you can remove it. So again, here when I specify it as a character, it'll work. Oops, what happened? Oh, put it in quotes because I defined that as a character. It has to go in quotes. Now it'll work because you define it as a character and kept it in quotes. Again, the length is a problem here. Again, because similar to data step, right? SQL also accepts by default 8th length of a character variable. Okay, so that's why it did not read the entire date. See, it read only up to 8 characters. So that's when you can always define the length this way. Okay, open braces and specify that you want length as a 10. Okay, now see. So this is how you can define a length. Okay, so open braces, and instead of length statement, you can just go specify that you want as a 10, and you can just specify it. So this is very similar to what you write, right? Dollar symbol 1 to 10 or whatever, right? So this is how you define a length here. I just increase it to 10. Now coming to date here, right? Let's run it. Now it'll work. But the problem is, again, since it is a SAS date value, sorry, SAS date constant, it gets converted into a SAS date value, a 5-digit value. The number of days difference between 1960 Jan 1st to the current date. So that's when you can write a format. You can write a format. Okay, so the format statement works in a different way here. So here in SAS, basically you are writing a format statement as a next statement, and you specify the variable here and you specify the format. Whereas in SQL, when you're defining it, the column name and the type of the column, it's numeric, and the format is equal to, you have to use format is equal to, and what are the formats you learn. You can use any other format that you want. Okay, so this is the only thing you have to remember when you're creating it in a data step. You do not have to, you can define it in any format, then you can define the in format. Whereas in SQL, you have to first put it in a date constant format. Okay, then that is the only way SAS SQL accepts this as a date. Okay, you cannot put it here. You can put it here, but you have to read it as a character. All right. So again, this is a very, very basic, simple one, right? Let's assume I just wanted to create So this is how we have, right? In data set, this is how we have data set. Okay. So now let's just run it. So again, you know the problem, right? So as soon as SAS encounters a space, it does not read it. Okay. So that's when we learned that how to define it. Okay. So let's say from 4 to 20, you can define it. We all know this column input method, whatever, right? Or you can just go right. Starting from at the 4th line, I just want 20 characters. I just want to read it. So this is a column pointer input method, which we use it. Okay. Now if you go X data set, it must have read it, right? So this is a column pointer input method. Okay, let's try to implement the same thing in SQL, and you would learn a new thing here. PROC SQL, create table. I'm just going to write X1. So I'm just going to have ID as a numeric, name as a character. So again, the same issue will happen here. Insert into, I'm going to insert the values, insert into X1. The first one is 1, 2, 3. And the name is, so let's say I'm going to write John Doe and insert. Okay. All right. So we were trying to replicate what we did. What we did in data step. So okay, so I'm just going to write quit statement here. Now let's just observe. Okay, so this worked here, more than 8 characters. Now let's see what's going to happen. So I just run it. Oops, did something again here. Oh, yeah, I always forget this. You have to write values because you're trying to insert values here. You just have to write values. Now go to X1 data set. Okay, so if you see here, it is also restricted to 8 characters. Okay, it is not reading more than 8 characters. So you do not have to specify. See, even though it has a space, SQL will be able to read it. Even though you have a space, it reads up to 8 characters. So all you have to do is just increase the length. You do not have to worry about the column pointer and specifying the length. You can just, because it is already separated by comma, you do not have to worry about from which position you want to read it. So all you have to do is just increase the length. It should be able to read it. Now let's go here. See, it read. No issues. So this output and this output both are same. Okay, so this is how we create it. Okay, it is just a very, very, very basic one because you are never going to create data sets. I mean, almost never. You're never going to create data sets this way. Okay, but this is just to get you started on how are we going to learn it. Okay, so this is how this entire exercise is going to be. We are going to compare what you learned in data step already, and then we do it with SQL so that you can have a side-by-side look and decide which one is easier, or even if you don't know. And again, it's more of a recap, right? We are just reiterating what we learned in data step. So this is the exact way you have to learn so that you do not have to spend too much time on understanding because you already know data step and the methodologies. All right. So now, so creating a data set from a SAS data set. So let's assume, how do we create a data set from a data set? Okay, for example, in SQL, in data set, basically, we use set statement, right? So basically, when I say creating a data set from a SAS data set, what does that mean is we are basically creating a data set called X from this SAS data set, which is already there, and we are using a SAS statement. Okay, so in SQL, what we are going to do is, so the PROC SQL, this would remain same. Again, create table, which is like data, it is going to remain same. So from here, again, we are not creating anything, right? As a set statement here, we have a select statement, which would work as a set statement, okay? Which would work as a set statement. For you have to understand that this as select star from SAS.class, this will work as a set statement. So in SQL, this is what we are saying, that I want to create a table one called X1 as select. You want to select asterisk or star symbol here, meaning everything from this data set, from this particular table. Okay, so you run this one. you basically know that it is just going to read everything from the SAS class data set. So work.x has 19 observations and 5 variables. So we are doing the similar thing here. So again, you have to, however you want to understand. Okay, so the way I understand it, okay, when I learned was, so create table x1 is nothing but this data x, set SAS class is nothing but as select. So star basically selects everything from this particular data set. So from is basically from which data set you want to read it. Okay, so run it and look at the output here. Go to the log, see table work.x1 created with 19 rows and 5 columns. So pretty much same as the previous one, right? Pretty much same as the previous one, which has 19 rows and 5 columns and 19 observations and 5 variables. It is just a nudge. Nothing changes, okay? The lengths, variable names, and everything will remain in both the cases same. See here? See here? Both are same. So there is no difference. Now, we learned about this one, right? Now, controlling the data set or table in data step versus SQL. Okay, so how do we control it, right? In data step, we learn data step options. Remember? So we learn data step, data step options. So which are basically we learn some of them as set options, so which are used to control the data set. So when I say control the data set, you are trying to create a data set, but you do not want the entire thing to be passed in. Okay, for example, we have OBS, we have first OBS, we have keep, we have drop, we have rename. Okay, so these are the options, or we have where option. So these are the options we looked at, right? So let's see how do we do it in SAS and how do we do it in SQL. So these options can be used in SQL as it is, but these options are restricted only to SQL. So outside SAS, you can go right this way as it is. Create table as select star from whatever the table you have on, let's say you are using Oracle, whatever the table that is available on Oracle, you can use it as it is. But these options, OBS, are, whenever I said these data options are set options, these are restricted only to SAS. Okay, you cannot go and use them outside SAS. But whereas in these particular statements you learn, these can be used along with as it is outside SAS. Okay, some of the systems won't accept semicolon, some of them will, and you do not have to use PROC SQL and quit. Quit mostly will, quit also will not be required by majority of the systems. Okay, now how do we use these options, right? Let's say I just want to write keep only name and age. So now what's going to happen? It is just going to transfer only 2 variables, name and age. Okay, so the same option can be used in SQL too. Okay, so we can go right PROC SQL, again create table x1 as select star from, I'm selecting everything, SAS dot class. So you can specify, so just like you specified in set statement, you can specify the variables you want. Okay, I'm just writing name and age here and run it.
Quit, right?
Yeah, run also works here. Run also works.
Okay.
But if you look here, the run statement has no effect. Okay, but again, if you place your cursor here, see it is still running.
Okay.
Okay, so that's why if you want to close it, saying that okay, don't run anymore. This is the end of the step. So that's when the quit occurs. Now run it. If you go look at it, it is the same output as the previous one. There is no difference, right? So this is just one option. Okay, the same way, if I want to use OBS and first OBS, you can use it. But again, I'm repeating again, there were people who came back to me and said, I'm using SQL Assistant to query some data from SQL database. Again, that is not SAS. They have that tool they are using to get connected to SQL database and use it. And they're saying that, okay, I still remember one of the guys came back and said, I'm trying to use OBS and first OBS on SQL, okay, not in SAS. I'm trying to use them on SQL. They're not working. They won't work because these are restricted to only SAS. Okay. So now OBS is equal to 10. We all know how it works. See, it read the first 10 observations. The similar option can be used here too. So I can just go right. OBS is equal to 10, and it just reads first 10 observations. Okay, the same way, if you want to rename or where option also, you can use it, right? For example, let's say I just want to filter only so this is how we write, right? We all remember this. So which will filter only the mails, right? Similar thing we can do it in SQL too. You can just go write where. So the similar setup, write it. So it also transfers only the gender, okay, whatever the condition is made. So these options can be used. So apart from that, SQL has two options which are similar to apart from what you see here, the OBS and first OBS. The SQL has its own OBS and out OBS options. Okay, so some of them are PROC SQL. You can specify that how many options you want. Okay, you can go right, create table x1 as select star from SAS class. Okay, so because the in OBS option works in SQL. Okay, this won't work in data step. Okay, in data step you always have to use OBS or first OBS. Here you have in OBS option. Okay, so just run it. So this will do similar thing to what we did before. Okay, it also read first 10 observations. First 10 observations. See, only 10 records were read from the data set due to in OBS option. So same way, we have out OBS option, which will also give 10 records. So if I say out OBS, it will also give first 10 records. Okay, but you can ask me now. So both are giving me the same option, right? So in OBS and first OBS, both are giving the same option. So which one works better, right? So the in OBS basically reads the entire data, then takes only the 10 observations. Whereas if you see here, statement terminated early due to out OBS option. So it doesn't go to more than 10 records. It just reads 10 records. Whereas in here, it reads the entire data, then finally it takes only the 10 records. So if you have, let's say 10 lakh records, so it reads the entire 10 lakh records, the final output would be 10. Whereas in here, it will just take the 10. Okay, so that's in OBS and OBS, out OBS, and these functions won't work in data step. Okay, again, you can always use them together in OBS and out OBS, just like OBS and first OBS together. But again, it's your choice. Okay, whether you want to use OBS and first OBS or in OBS and out OBS, you can always choose. Okay, now, so this is similar to OBS and first OBS, right? The similar way, keep and drop equivalent in, right? Keep and drop equivalent in SQL. Okay, again, we learned you can use this keep and drop options in SAS. Okay, but outside SAS, you will not have those options, right? Let's say you are using SQL and you do not have those options. How do you keep or drop the variables, right? So in SQL, if you want to keep or drop options in SQL, this is how you do it. Okay, so you can select those by commas. Okay, so instead of asterisk, you can just go say that these are the columns I want. You just have to specify, separate each and every column with a comma. Now run it. So this is nothing but keep option only. Okay, so if you see here, only 2 columns have been kept. So again, there is no drop to it. Again, there is no drop equivalent. If you want to drop some variables, all you have to do is specify this way only. So let's say you want to drop these 2 variables. So you have to specify, let's say you have 100 variables, you want 98 of them, you have to specify 98 of them, because select statement does not drop the variables, it only includes the variables. Okay, now this is one option, right? So where statement, right? We have where statement in SAS. So where statement in SAS versus SQL. Okay, where statement in SAS versus SQL. Let's see. You write data x set SAS class. Again, I'm not talking about where option. I'm talking about where's option. Okay, where sex is equal to male, you right? Again, if you want to use it as an option, you can use it. There are no issues, right? Instead of specifying it as a statement, you can go and specify it as an option. So in SQL, you have where class, create table x1 as select star from, because I want everything from the data set, SAS that class. So next, after from statement or from class, you have a where class. I'm calling them classes again. You would know it in a bit. Why am I calling them a class? So now this is it. Okay. So after from statement, you just have to specify where. And look at the SAS data step versus SQL here, right? In data step, everything is a statement here. Everything is a statement. Okay. These are called procedural statement, where SAS goes by statement by statement. Whereas in here, if you look here, everything is one query here, right? So from create table to where here, everything is one query. So if you look here, you have create table as one statement, select as one as one statement, select as one statement, from as one statement, and where as one statement. So from here to here, everything ends with one semicolon. So create table, you have to consider it as one statement that has some sub statements that ends with one semicolon, unlike in data step. So this is a hard thing to remember, especially if you are starting. But yeah, so this is the only way. Yeah, you have to remember create table ends with one statement, and you pass multiple statements inside it, like select, from, where, here. So this is how we write where statement in SAS versus SQL, right? So again, you can write anything, okay? Any operator that you learn, let's say where sex is equal to male and age. Again, it's case sensitive. Again, SQL is also case sensitive. You can put them anywhere you want. So I just wrote sex is equal to male and age greater than 13. So the similar thing you can do here too. Age greater than 13. So run it. This will produce us the same output, and this will produce us the same output. Now let me ask this question. Okay, I always ask this question. So far you looked at some of the statements, right? Which one do you think is easier? Let's say I ask you to filter a data set and I'll give you columns. Which method you choose? Which one do you think is easy to remember or easy to write? You can ping me your answers. There's a reason I'm asking. I ask this everybody. Data step, thank you. Tony SQL, so far data step, thank you. Shanmugam. Correct. So Tony said SQL because he might be familiar with SQL already, isn't it, Tony? Are you familiar with SQL before? I mean, at least a little bit, right?
Yes.
Yeah, so that's why he found it very easy, okay? Because again, I've seen a lot of people, okay, who come from SQL background. They would always say, I find SQL a lot easier compared to data step, okay? Because there as to it. So Nitya and Shanmugam and Vani, you said data step because you are familiar with data step. Again, there's no wrong answer in this. Either you can use data step and PROC SQL. If you are trying to, both are achieving the same thing, right? Both are producing the same result. But of course, the performance, which one works better, which one runs faster when I submit these queries, again, we'll learn them later. But for now, remember, it's always your convenience. Okay, nobody's going to force you to write entire thing in SQL, or nobody's going to force you write this thing in data step. Okay, if Tony wants to write it in SQL because he finds it easy, he can always write it. The same way, if you feel that I am comfortable with data step, I don't want to write it in SQL, you can always write it. So that's where the real struggle begins, right? So you might find, okay, I'll write everything in SQL. You can always write it, certainly. But there will be cases where you must write like arrays and do loops. We do not have those concepts in SQL. Okay, again, you will know why. So certain cases, let's say you are trying to use arrays in SQL, you cannot use them. So you must use data sets. So that's why it's always better to have the same amount of knowledge or same amount of grip on both the languages, both data step and SQL. So you can always switch. So you can always write whenever you feel that PROC SQL is a lot easier in these cases, you can always write SQL. If you feel data step is a lot easier, you can always write it. But there are cases where you must write them in SQL. There are cases where you must write them in data step. Okay. Yeah, so we'll slowly look at them. So this is how we write in data step. Okay, so all those operators that we learn like between operator, greater than or operator. So we write this way. So the similar stuff, right? What are the operators you learn? Greater than, less than, anything that you learn will be same here. Okay, again, you do not have to worry about what options I should use, anything. Okay, see all these options. Okay, all these operators you learned, all those conditional operators that you learned, everything, right? That can be used in SQL too. So absolutely, there is no difference between here and there. Okay, so yeah, so far I'm assuming you are catching up. I know, again, if you practice them, then only you'll get them. I'm only asking you to just understand the differences. Of course, when you start practicing, you'll always find it easier. And this is another way I suggest, in order to learn SQL much faster in SAS, always write what you know in data step, because you'll be doing two things. You'll be writing data step and the same thing in SQL, so that you'll have equal amount of knowledge on both of the concepts. Okay, so always write it this way, especially when you're practicing, when you're trying to learn SQL. Don't stand alone practice this one. Okay, always write this one first and then try implementing this one. Okay, so the reason I'm saying, those 11 tasks you did, remember, what are the 13 tasks I gave you, the base SAS tasks, you have to do them in SQL too. So the entire thing that you did using data step, you have to do them using SQL too. So that's where, because 95% of what you did there can be done using SQL. So that's how you understand. Okay, you learn SQL fastly, right? Because you already did it there, right? Now, before we move further, right? Select class order. So outside SQL, basically, outside SAS, basically, we are calling them select statement, from statement, and where statement. Okay, basically, outside in general SQL, we have to call them classes. Okay, again, so this is the select class order. You have to remember. Okay, so again, some of them we haven't seen them. We haven't seen them yet, but yeah, we'll be learning them. So these are the classes. You have to remember them. So select is the first one, from, where, group by, having, order by. So this is the order of the statements. If you look here, we already learned three classes here. We learned select class, from class, and where class. So if you see here, select class is basically selecting the columns from the table, and from is basically specifying the table, from which table the data has to be read, and where statement is basically subsetting the data, filtering the data. So you always have to follow this order. Okay, you cannot write from first and write select statement next. For you, it is easy to remember, because the same way you learn, you always have to follow the order, right? Data, set, where, here, what you followed here, the similar thing. Okay, but you have to remember this order always. Okay, so eventually we'll talk about these statements too. Okay, now creating a new variable in data step versus SQL. So how did we create a new variable in SAS, right, in data step? So for example, I just want to create a new variable called location. So I would just go write location LA. So here a location called LA will be created, and you'll have an uniform value called LA under location column for this. Okay, so this is how you create it. This is known as an assignment statement in data step, right? So whereas in SQL, this is how you create it. So you go right, create table. So you select, again, you select everything, select star. So star selects everything, and you want a new variable. So this is how you write it. Okay, so first you define the value you want, then you write as and you define the variable name. Okay, so again, pretty simple thing, but again, there is a difference of how you write it in data step and SQL. So if you see here in data step, after set statement, you define the variable name first and then you define the condition. Whereas in SQL, first you define the condition, which is the value that you want to input. And instead of is equal to here, you just specify as and you specify the variable name here. So now if you run it, so this will also produce the same thing. See, x1 has the same output and the length and everything will be same here. So the length here will be 2. Here also the length will be 2 here. So this is how you define a new variable in data step versus SQL. Okay, again, you have to remember after asterisk, you have to put comma, and SAS understands that you are trying to define a new variable, and this is how you define it. So this is how it works outside SAS also, right? You have to define it this way. Okay, you can choose more than one variable also. Okay, there is absolutely no restriction. So for example, let's say I just want to write new age is equal to age plus 2. So I want to perform some mathematical operation here. So I run it. So new age is equal to age plus 2. The same way you can go here, location, comma, because you are defining the new variable. First define the condition age plus 2 as, and you define the new age variable. Now run it. See now the new variable has been defined. So both the outputs are same, right? So likewise, any conditions, you can build a number of variables. Okay, again, after you want to create 10 variables, you can create 10 variables here, right? Now let's just say so where and if versus in SAS versus SQL. Okay, let's see, we all remember where and if, right? The difference between where and if. So let's say I create a new variable called new age, and I'm just multiplying. So can I write where here, where new underscore age? Let's say if I want to filter out the values that are greater than 26, does it work? So we all must know this, right? So does this work? If I write it this way, you can ping me your answers. Does it work? You can ping me your answer. I'm just trying to understand. Okay, if you remember this. Perfect. Thank you, Tony and Shanmugam. Right, it doesn't work, right? It does not work. Okay, because where statement works to filter, where statement processes it first, so it does not work. Okay, so you must use if statement here, because if statement filter, the new wage will be available on this data set, X data set. If you are trying to filter the data from any variable which is available on this data set, then you must use if statement, because new age will not be available on this data set because you're creating it in this one. So in SQL, the similar thing will happen. So now let's go here. Before we write now if, right, let's just write where statement and run it. And what is the error you get? So variable new age is not on SAS.class. So that's what it says. It is telling you that new underscore age variable is basically not on SAS.class, because as a where statement, I only filter the data from this data set. So that's when you learn to use if statement to filter the data. The similar thing in SQL, right? So you go write PROC SQL. So again, as usual, you write create table, you create a new variable, create table x1 as select star comma, again age into 2 as new underscore age from SAS dot class. Okay, now try running where new underscore age greater than 26. Okay, so here also let's see what's going to happen. See now, it says the same thing, just as a previous one, right? It says variable new age is not on SAS class because you're trying to use where statement. Here also it says the following columns were not found in the contributing table. So it is also same, okay? Where statement only works if you are trying to filter the data from this data set. So here we used if statement, and remember, if statement is not available for procedures except PROC report. So PROC report also to compute new variables. Again, only in PROC report you can use if statement, that to compute new variables, not to filter the data. So whereas in here we have a statement called we have a class called having. Okay, so having is nothing but your if in our SQL. Okay, again, having in SQL, in general SQL, has a whole different meaning, but for you, since you started in SAS, remember if is equivalent to having in SAS. Okay, now let's just go run it. Now it must have worked. Okay, so the previous output and this output will both be same. So X data set, you have 9 observation that I ran through data step, and here when I run it, so if I go here, it must have the same amount of observation as the previous one because the output should be same. Okay, so remember again the class order. Again, you have to always go back and look at the class order here. If you see here, see select, I use select to select the variables. From, I defined it. Again, I do not have where statement here. Again, there is no rule that this should always be together. Now, but when I use group by group, when I use having always come after from statement, after from class. Okay, this is the order you have to follow. I cannot go put having before from, it doesn't work here. Okay, you always have to follow this order. So that's the difference between the if statement, where and if in SAS versus SQL. Okay, so whenever you think of if statement in data step, it's always having in SQL. It is always having in SQL. Like I said, if statement is not available for process, it is available only for PROC report. So in SQL, you have to use having instead of if here. Okay, but rest of the stuff is same. Okay, any conditional processing, any filtering conditions that you want to add using having on the new variable that you created, just like new underscore is here, because that is available on this data set, not on this. You can use any condition here. Okay, now.
Hey, Gangadhar.
Yeah.
So in the data step, we used to semicolon for separate, right, where or if statement. But here you are writing continuously.
Correct.
There is no semicolon.
No. So all these classes end with only one semicolon. Like I said, right? So create table till whatever you lent here, all these classes ends with only one semicolon.
Okay.
Yeah, that's again another thing you have to remember. Yeah, so it will take time because again, it's good that you remember that each and everything ends with set statement. That's how you exactly have to understand it. But when it comes to SQL, it runs things differently. But as long as if you remember this, it's not that hard to understand. Okay, so you write a couple of queries and you get used to it. Now, conditional processing in data step versus SQL. So in data step, basically, we know that if else conditions we can use, right? So I would go write data x set SAS help dot class. I would write where, if sex is equal to male, then let's say I want to write location is equal to LA, else if sex is equal to female, then location is equal to CA. So we all remember this method. Okay, this is how you write conditional processing. So again, we cannot use if else conditions in SQL. So in SQL, we have case when else conditions. Okay, case when else conditions. So your if else then is nothing but case when if else then. In data step, in SQL, we are calling them case when else statements. Okay, PROC SQL. Now let's look here. PROC SQL. Okay, so select. So I'm going to select everything. Again, since it is a new variable that you are creating, right? So this is where it starts. Okay, so you write case when, just like if sex is equal to, so you define the condition case when sex is equal to male, then you define the value that you want to assign, then LA. So unlike here, you define the variable name, you don't define the variable name here, you first define the condition, then LA, and else condition. So since it is another condition, right? So you do not have to write. So you define another when condition instead of else condition. So this will directly work as else condition here. Okay, so you define. So if sex is equal to male, then location is equal to LA here. Case when sex is equal to male, then you define LA here. Then your second condition, you can write it here. You have to define a variable name here. You define it as an end statement. Okay, so end statement, end as is an option that you have to use it to assign it. Okay, now this is how it works. So let me break it into another line so that it will be a lot easier to understand. Okay, you can always write them in one line. For our convenience, I'm just writing. Okay, so in data step, you write if sex is equal to male, then location LA. So first here, you write case when the condition here, then you assign the value first. You don't assign the variable name, you assign the value first. Then your else condition, else if condition will straight away when condition here, when sex is equal to female, then CA. So at the end, using end as, you would assign your variable name here, just like here, location, then after you wrote, we have to always use end as location. Now let's just go and run it. Okay, now let's just go run it. Oops. What am I doing? I'm missing something. Missing something here. Syntax error.
Even in the quotes?
Yeah. No, see, I missed the from statement here. So I have to define from, right? Yeah, from statement. So here to here, you define the variable, the condition here. So after that, again, the from has to come because again, it is a new variable you are creating. It's not the quotes. It is just the table name I missed. Okay, again, now run it. You'll see no issues. Okay, if you go to X data set, it has C, LA, and CA, and you would expect the same thing to be assigned to this X1 too. And similar, right? So this is how you basically assign a case when, right? Again, you can write multiple conditions. Okay, again, unlike here, you do not have to write another else condition. If you have another if condition, you can always go and specify with a when directly. Okay, no commas, nothing. You can. This is one condition. The second condition can be without comma. You can just define it. Okay. Only thing is you have to always send it with the variable name. Now, let's see where does the else condition comes. Okay. So let's assume. So this is how it works, right? So the else condition here, we all know, right? So only for the male, gender male, the location will be assigned. For location LA will be assigned. For anything other than male, the location CA will be assigned. So the similar way in SQL 2, if you want to use else condition, you can write it this way. So you can go write else CA. Okay. So anything apart from oh sorry.
LOC, right?
Oh, sorry, I missed that. Okay, good catch. And as LOC. Okay, so I defined the variable name. Okay, so now if you see, it must have worked. So again, this and this both are same. Okay. If you want this particular way, let's say you have multiple conditions, right? Data step, you can go data exit SAS class. If age is equal to 11, then location is equal to, let's say, CA. Else, if age is equal to 12, then location is equal to age is equal to 13, then let's say location is equal to. Now PROC SQL create table x1 select star comma. So case when first you define your condition age 1, then let's say CA. Now instead of that else condition here, you can go and say when age is equal to 12, then let's say NY, because it acts as an else condition by default. All right, so okay, so end as location. Okay, so the same way, okay, you can, as long as you do not have else condition, same way how you specified there, you can always define it. Okay, now if I go here and run it, so the output should be both same in both the cases. Okay, so LA NYCA for what are the conditions it is met, and you have the same thing here too. Okay, yeah, so I'll stop it here. I know it's too much information because those who are new to the SQL first time, you need some practicing. Again, because we are going to learn a lot of, I mean, again, this entire thing is going to be like this. Okay, the entire SQL components is going to be like this. We will just reiterate what we did in SAS, in data step, and we will try to do the same thing. Of course, there are certain stuff we cannot really compare. We must do it with SQL directly. So that's but like I said, 90% of the stuff we can do it here, what we did in data step. Okay, but some of the statements you learned in data step might not work here, are not available. That again, I'll tell you what statements are not available. All right, so spend weekend again. You do not have to go in detail. At least, you know, these are very basic syntaxes, right? So if you can get used to the SQL style of learning too, so that it will be a lot easier for you. Okay, all right, so if you don't have any questions, I'll see you on Monday. And Nitya, I remember, so I'll share those the answers for the base SAS questions. And I remember I owe you the arrays, some more exercises. Okay, I'll try sharing them this weekend. Thank you so much. Happy weekend, everyone.
Thanks. Have a nice weekend too.
Thank you. Okay, so we were talking about. So this was the last concept we talked about, right? The conditional processing between SAS and the data step and SQL. So likewise, I hope you all had a chance to practice, especially for those who are new to the programming. Especially if you did not know SQL, I'm guessing you practiced and there were no questions. All right. Okay. So let's go ahead a bit. Okay. So we talked about the basics, right? Options and the syntax difference between data step and PROC SQL. So we talked about how do we assign new variables between SAS and data step and SQL, and we looked at the conditional processing too. Let's look at how do we assign dates, right? So assign dates. Okay. Again, it's going to be the same as data step. For example, in data step, let's say you want to assign a date. So we all learned about this one. Okay, let's say date of joining. So I'm just creating two variables here, date of joining and record date. So date of joining. So again, if you are hard coding the date, So you have to write it this way. Remember date9 format and in quotes D, which is known as date constant, whereas in so this is how you assign formats, right? So if I run it, so what's going to happen? You are going to have two different dates. One is DOJ, another one is recorded date. Okay, the same way. Let's see how we assign the dates. Okay, the similar way how we are going to assign it to. Okay, so this is how you write it. So again, the syntax would remain same. You would go right, create table. Let's say I'm going to create x1 as select. So you are going to select everything asterisk, and you want to define the date first. So similar syntax as the data step, and then write DOJ, comma, and you want today as, so first you define the condition or the function here, and then write the variable name. Okay, so recorded date. So from as help.class, again you have to remember the class order and quit. Now let's just see what's going to happen. So similar to what happens to SAS here, it is going to convert it into a SAS date value here too. So again, unlike in SAS where you can define one single format statement and define multiple variables here, so here you have to define it for each and every individual variable. Okay, so you would write date9, and you would also write format is equal to date9, and then so make sure there are no semicolons. Now run it. See, now it changed. So any other formats that we learned, right? So if you want to convert it into MMDDYY, so the rest of the stuff, the functionality you learned in data step, all the formats and informats, everything would remain same here. So there is no change. So this and this would be same. Okay, but only thing is you have to remember the syntax. Unlike here, you have to define format and specify the variable name here. All right. So this is how you work with dates. Again, if you are trying to filter the dates in the data step here, and everything is in the filtering conditions, whatever you learned here, the syntax wise and everything would remain same here. And you have to remember the class order. All right. So that's how you handle dates in data step versus SQL. Okay, PROC SQL. Okay, let's go a little a bit more. So one of the cases we have to see is using functions in data step versus SQL, right? In PROC SQL. Whenever I say SQL, assume it is PROC SQL. Okay. So in data step, let's assume I want to convert name. So let's say I want to create a new variable called new name, and I want to use a function called upcase. Okay, upcase of that particular variable. So this is how you write it, right? So you write it. So a new variable called new underscore name will be created, which will be the uppercase of the name variable. The similar way, so we go create PROC SQL create table x1 as select asterisk. So first you define the function now again here, upcase of name as new underscore name from some SAS class wait. Okay. Now if you go here again, everything is been converted into uppercase. So again, you have to remember the functionality. Okay, here you define the statement first, and then you define the function. Here you define the function and you use as statement to define the variable. So likewise, you can use any functions that you learn in data step. Okay, for example, in data step we learned a function called any alpha. Okay, I'm just giving an example. Any, I'm going to call it character any alpha. So we all know any alpha, it returns the first position of any alphabet. Okay, so since I'm choosing name here, so in the name variable everything you have is character, so it's going to define it's going to get you all the alphabet. So the first position. So the same way in PROC SQL 2, if you are trying to define so any alpha name as any character from SAS dot. Okay, so now run it. So it will also produce the same output as the previous one. Okay, so this is just an example how you can use it. Okay, even we have the date functions, right? Sorry, set SAS dot class. Let's assume you have let's say I just want to advance a date. I want to advance a date from today. I want to advance the date to 100 days and say what is the date. So I hope everybody remembers this function. Format after 100 days. Date 9 and run. Okay. Now let's just run it. So again, after 100 days, that would be the date. Okay. So here we are using the date functionality int next. So I'm going to do the same thing here. PROC SQL. Let's create table x1 as select asterisk. So you can use the same functionality as it is. Again, remember the rule, the first variable, then so this is one example, right? You are defining it and you are finding it out. Now x1, if you go, so it must have got it. Again, you know that you have to define a format, because just like data step, again, whenever you're trying to create a date, it first converts it into a SAS date value. Now, if you go here, it must have worked. Okay, so the output that gets produced from this and this both are same. So the bottom line is any functions that you lend in data step, let it be a substr function, a scan function, or any function, okay, it is going to be same. All right. Now, underscore and underscore equivalent in data step versus SQL. Okay. Okay. So here is a question for you. Okay, just to test your knowledge. Data X SAS dot class. I'm just gonna write OBS is equal to underscore. So what's gonna happen here? So if I run this query, what will be my output? Okay, you can ping me your answers. I just want to make sure you all know what does underscore and underscore mean. Okay, you can ping me your answer. Ping me direct. Okay, send me direct message. Perfect. Perfect. Thank you, Nitya. Thank you, Tony. That's perfect. Perfect. Yep. So when I run this, so it is going to have a new column called OBS, and OBS will have each observation. Okay, so underscore and underscore typically what it does is, again, when we learn program data vector, each observation it ran, SAS runs, it creates two automatic variables known as underscore error underscore and underscore and underscore, right? We all remember that concept. So underscore and underscore is nothing but one observation per record. Okay, so it's nothing but a variable which it will produce a numerical value, right? So the same way in PROC SQL 2, so we do not have underscore and underscore there. So let's go here, right? So from SAS help dot, so we do have a different functionality. So run it. See, it says the following columns were not found in the contributing tables, okay, underscore and underscore, because SQL follows the query by query approach, so that's why it doesn't have this functionality. Okay, so let's see how do we assign this way, right? How do we assign this way where each record? Okay, so this is very, very important. I have seen this question being raised by a lot of SAS programmers, especially during the interviews. So we have a function called monotonic. So this function, so you can just choose any variable here. So monotonic is a function basically which assigns the row number to variable sequentially. Okay, so when I say monotonic of name, so basically you are asking it to assign the observation number for each and everything. So from SAS help dot class and run it. Okay, so now let's go look at it. So if you look at it, the x1, see this output is same as this output. Okay, there would be another concept, right? Let's assume I just want to filter. Let's say this again is a logic I'm talking about. I just want to filter first observation, 7th observation, and 10th observation. Okay, in data step, this is how you write it. Okay, where if underscore and underscore in is equal to in 1, 7, 10. Okay, so it will have 3 records with the first observation, 7th observation, and 10th observation. So whereas in SQL, this is how you write it. Okay, create table. Okay, x1 select star from class. So you go right where monotonic. So here you have to choose one variable at least. Okay, so name or age, any variable in 1, 7, 10. Now what it might have done is it might have extracted the 3 observations, the first observation, 7th observation, and 10th observation. Okay, which is similar to this particular data step methodology. Okay, so yeah, so underscore and underscore n is equivalent in SQL is monotonic function. Okay, but only difference is you have to assign it a variable, so to fetch the record number. Okay, so that's how it works. Now in PROC SQL, right? Let's see deleting duplicates between SAS versus SQL. Okay, again, I'm not calling it data step because in SAS we have this PROC sort, right? What PROC sort basically, which deletes the duplicates. Okay, let's assume I have ID, age, salary. So 1, 2, 3, 28, 2000, 1, 2, 4, 29, 3000, 1, 2, 5, 3000, 1, 2, 3, 28, 1, 2, 4, 30. Okay, so this is how you have it. So let's just assume I just want to delete the duplicate ID values. So which means I just want to delete the duplicate ID values. Okay, 1, 2, 3, and 1, 2, 4 are the duplicates. So in data in SAS, basically you lend a procedure called PROC sort, where you would go write. There is an, we all remember, right? So no dup key, and you would write by ID. So it will delete the duplicate IDs by duplicate keys by this ID. Okay, so that's the whole point of having no duplicate statement. Okay, if you want to delete it. So if you go, so sorry, I took the data set out, right? So out I have taken. So you have to look at here. This is after the deletion, 1, 2, 3, 1, 2, 4, 1, 2, 5. Okay, so here I used only ID, right? So in SQL, but you have to remember here, okay, you deleted it. once you deleted it, it also written the other observations, right? Other variable values. Okay. Whereas in SQL, it is going to be different. Okay. So you have to, if you want to delete duplicate observations by a single variable, so you have to go write distinct. So there is a command called distinct. Okay, it's a distinct statement. Okay, in SAS, distinct or ID. You have to choose only that particular ID variable. Okay. Now the problem is it is going to return only that particular variable. Okay, it doesn't see it deleted the duplicates, but unlike in SAS, you returned all the other variable and observation values also. Okay, so in SQL you have to choose only that particular variable. Okay, so now, so this is where the problem begins. Okay, if this is your first what do you call advantage of data step over SQL, because if you are looking for information, okay, especially in this scenario, you just want to delete it by ID, but you still want to have other ages and salaries, okay, the other variable information. So data, the PROC sort is a very easy way to do it, okay, because though it is deleting the duplicate IDs, it is still retaining the other variable values. Whereas in SQL, you do not have this functionality, okay, you cannot retain them by default. So whenever you save the variable name, so it is going to take it. Okay, you might ask me, so can I keep star asterisk, right? Asterisk and distinct ID. Okay, see, so it is not going to accept that. Okay, so basically you cannot have asterisk and, see, now I'm trying to first select it and produce it. Okay, so it is not going to accept it. Okay, so that is the problem. In data step, basically have to select only one variable if you are trying to delete by duplicates. Again, you can rejoin it or whatever. Okay, again, we'll talk in future classes, it will make more sense. But for now, this is where your first advantage of SAS comes over SQL. Okay, you want to delete the duplicates and you still want to remain other variable values. Now let's go here. So here, if you ask me, deleting duplicates by ID is the wrong thing, because you might have ages and salaries different. Okay, so that's when in data step, what would we do? Or in SAS, what would we do? We include two variables, right? PROC SQL, you would go right, create, sorry, PROC sort data is equal to X. You either write no dupe, or no dupe records by ID. So now what happens? So first it sorts the data and it checks by the record. Okay, if by ID everything is same or not. Okay, the record has to match. So in this case, it must have not, because the order itself is different. Okay, so 1, 2, 3, you are still deleting it by ID. So here, if you see, now it tried deleting the duplicates by ID. If you see here, 1, 2, 3, 28, 2000, you don't have another 1, 2, 3, 28, 2000. Okay, so that's why it still remains same. But whereas in, let me change this one. Now you would, so how many records have to be deleted now? If I run this, how many records have to be deleted? Okay, you can ping me your answers. Okay, so here, see now, by ID I'm checking, right? Okay, again, everybody ping some answer here. Yeah, none, because, so let's assume this is how the data sorts are. Okay, first this 1, 2, 3, 28, 2000, this 1, 2, 3, 20. So you said by ID, so it has to check by the ID for the entire record. But when it checks, this is different and this is different, so it will not be a duplicate record. So 124, 29, 3000 and 124, 33,000. So because by ID you are checking the entire record. So that's the whole point, right? So again, if I tweak it now, how many records will be deleted? Take your time. Yes, now it will have two records deleted, right? Because you have by ID, when you check, 2 rows exactly match. 2 rows exactly match. Okay, so now 2 have been deleted. Okay, so that's how it works, right? No duplicates. Now, if you want to do the same thing in SQL, so create table. If you want to check by the entire record, okay, to check the non-duplicate or to delete duplicate records, so which means you want to check by the entire record. Okay, so just like what you did, you specified by ID. Basically it is checking the entire record by ID. Okay, so here you can go right, select distinct star from X. So now what is going to happen here? It is going to check the distinct record. Star is nothing but for the entire thing. Okay, for the entire thing. So when I run it, if I look at it, so it will have the same output as the data, the sort one. Okay, so here distinct star selects each and every record, and if it finds duplicates, it deletes them. Okay, so which is similar to this one. Or in SAS, again, it's a lot easier even if you write by underscore all underscore, right? If you write by underscore and underscore, so basically it is going to check the entire record, okay, by all the variables. Okay, underscore is nothing but by all the variables. Okay, so which one? This one and this one would be same. Okay, where you want to check by the entire record. So that's how the distinct will work. Okay.
Hey, Gangadhar.
Yeah.
So the PROC SQL, for this, you don't need to sort the data, right?
No.
So you directly go with PROC SQL instead of sorting.
Correct. Yep. You do not have to sort the data.
Okay, so that's actually saves some space, right?
Exactly. That's what my next topic would be. Okay, it saves a lot of time because you do not. So in SAS, what's going to happen? Every time you write proc sort, you specify by statement. Even if you are trying to delete duplicates, it is going to remain same. It's going to sort the data, right? Whereas in SQL, it doesn't here. It just deletes the duplicates and keeps the data set as it is. So it saves your time.
Can we do like a no dup key here?
In SQL, no, it won't work.
Okay.
In SQL, no, it doesn't work. You always have to depend on distinct only based on your context.
Okay.
All right. Now, so in SAS, right? So let's assume. Okay, let me give you a small scenario. Okay, this is again we have to learn it by scenario. So there's no what do you call? Let's say ID. Oops. ID. Gender, location I have. Okay. So if I ask you to find out what is the count of each gender, or I want you to return how many values are there in location, how would you return it? Let's say how many LA values, and I just want to print only the unique values. How do you print it? Okay, let me repeat the question. So get only the unique location values. How do you get it? Get only the unique location values. In SAS, how do we get it? Perfect.
sort by location and no dupe.
Yeah, that's correct. That is correct. So we can do proc frequency to table. So if you write location, it will give, or we can. So this, oops. This is one method, one approach using proc frequency. Yeah, you are right, Tony. Yeah, this will also do it. So we have C, CA, LA, and Y. And if you want to take it into a data set, you can take it. Okay. Whereas we can also use proc sort and say proc sort data is equal to X and say no dupe key by location. Okay. Our out is equal to Y, take it and keep only location to get only the count, right? So this will also do the job, both, any of them. Okay, any of them you can use it as long as you're you know what is the output you're expecting. So this will also give me the same thing. Okay, so this output, so which gave me see LA, CA, and CA, LA, and Y. So this output also will give the same thing. Okay, so whereas in SQL, so this is what you do. Okay, you go write proc SQL create table. Again, we already have seen it because this kind of scenarios we will encounter in real time. Okay, select location. Sorry, select distinct location from X. So we already have seen this. Okay, but the context is different here. In the previous case, you wanted to delete the duplicates. Now the question changed: get only the unique location values. Okay. So which means basically somebody wants to look at how many locations are there instead of, they don't care about duplicates. They just want to see how many locations are there. Okay, so see this output and the rest of this output are same. Okay, and now the same way, get the unique local location values count. Okay, so maybe this topic we talk about a little bit. Okay, so yeah, so you understood the concept, right? The context here, basically, if you are trying to look for the unique values, from it, I mean, again, all it is doing is it is basically deleting the duplicates only, but you do not you change the context and saying that I just want to know unique values here, so this will do it. Now, sorting, we'll data set in SAS versus SQL. Okay, SAS versus SQL. Let's assume I have an X data set with information from SAS class. X data set with information from SAS class. Okay, so X data set is this one. Now let's just say I just want to sort the data set by age in ascending order. So what do you do in SAS? Basically, you go right proc sort data is equal to X. So let's take a new data set out by age. So this is how you sort it, right? By default, it just gives you an ascending order. Now, let's assume this is your context. Okay, in SAS, this is what the problem. Again, this is where SQL is more efficient than SAS. Okay, so here my requirement was I created a data set. Then on this data set, I wanted to sort by age. Okay, so I created this data set. Then I realized that, okay, in my data set, the age values are not sorted. I want them in sorted order. So what I did, then I had to write a separate step and sort the values. Okay, sorry. Now I had to use it separately and sort the data by age. Okay, it worked, right? But you are using two different steps here, which is a headache process. Okay, so now in SQL you can do this way: create table, select, you select everything. So you are going to learn a class called order by class. Okay, so this order by class will sort the data. So again, you have to remember the class order. Select from where group by having, select from where group by having order by. Okay, so here I'm using a class called order by here, which will, so again, here, these two steps are combined into one step here. So here, first you created the data set, and then you sorted the data set by age, and you took the data set out. Whereas in SQL, you created the data set. While creating the data set itself, you are sorting the data. Okay, now go run it. See now, this output and this output is same. Okay, instead of two steps, you just wrote it in one step. So this is how you use it. Okay, order by, order space by, and one variable. Okay, so again, if you want to sort the data by multiple variables in SAS, you go right. Let's say first thing, if you want it in descending order, so this is something again you have to remember. So if you want it in descending order, you would write it this way. You just keep descending before the variable name, so that your data will be descending, arranged in descending order. Whereas in SQL, so this is little different again here. If you want to sort the data, you have to write DESC. Do not have to write entire thing, just write DESC, but it has to be written after the variable name. Okay, in data step, you write descending before the variable name. In SQL, you write it after the variable name. Okay, so you go here. See, it is the same as the previous step. Okay, so you sorted the data in proc sort by descending here. You write DESC after the variable name. So now sorting by multiple columns. So sorting by multiple columns in SAS versus SQL. SAS versus SQL. Okay, for example, in data step. Okay, if I want to sort the data by let's say age and sex, okay, or sex and age variables, so you would write sex and age. Okay, I see a question here. Let me go. So yeah, so the question is, Tony, so this one, right, by age descending, it still works. Yeah, that's a good catch. Yeah, correct. So this is what he asked. Yeah, you can use it. Yeah, see, I just wrote descending, it still works. So the reason people don't use, I mean, descending, so if you write descending, it is not going to highlight it as a statement, because when it comes to SQL, they see it still worked. Okay, if you go here, still work, but the problem is the statement is not highlighted. So if you write DSC in start form, it'll work, and at the same time it will highlight. Okay, so the way it will be very easy to remember. Okay, but yeah, you can always write descending here, but only thing is you have to write it after the variable name. It doesn't work before the variable name. Now, so in SAS, right, if you want to sort two data, I mean by two variables, you would write this way. Okay, by sex and age variable. Okay, when you by mistake I ran the entire thing. Now it's okay. Now run it. Now if you go here, the Y data set will have all the females and then males in ascending order. Okay, so whereas in SQL, the syntax would remain same. Only thing is you would have to specify sex, comma, age. So the variable has to be separated by comma here. Okay, so sorting in SAS, this output and this output would be same. See now, there's no difference. So yeah, that's how you use order by. And again, if you want one variable in ascending or descending order, you write descending and you run it. So the first sex variable will be sorted in descending order, first males and then females. Okay, so which will be similar to SQL also. Okay, only thing is you have to specify after the variable name. Okay, the DESC or descending. So run it. See now, so it worked. So yeah, that's how you use order by. Okay, now in SAS, okay, creating summarized tables. So this is a very important concept, because most of the times people use SQL here in this particular scenario. Okay, SAS versus SQL compared to what we have in SAS. This is much more, SQL is much more efficient than what we have SAS. Okay, so let me just list out one example for you. Okay, you have to answer this. I have this data. Okay, now tell me, how do I summarize this data? So my final output should be, I need location and total balance. Okay, location wise total balance I want. Let's say LA, NY, and CA. So whatever, right? So this is how I need the data. So how do you, in how many ways you can do it in SAS? There are a lot of ways. You have to list out all the ways you know. This is a very major concept. Like I said, rather in SAS, people, especially if you want to create a summarized table. Now, I'm not talking about reports. I'm talking about if in real time you want to create a summarized table, you use SQL rather than what you have in SAS. Okay, so you can list out. Okay, there are some procedures we'll end, and in data step also we could do it. You can list out the procedures that you can do it in SAS. This is a very important concept. So I'm just going to give you 2 minutes. Think of it. It's fine if you don't remember. Okay, I'm sure you would understand it. Perfect. Thank you, Nitya. Thank you, sir. Shanmugam. Yeah, that's right. Excellent. Yeah. Go on. Okay. So yeah. So in SAS, okay, we have a lot of methodologies. Okay. So one of them would be first.id and last.id, right? So that would work. And PROC means we'll do it, and then PROC summary. PROC means same. PROC report will do it. PROC tablet will do it. Okay, so we can always look at them, right? So first.id, last.id concept, I'm sure everybody must, I mean, because you did those tasks, so you must be pretty sure, right? So I'm not going to go there, but since, okay, I mean, why not? Okay, let's go there too, right? So that since we are writing it here, PROC sort data. So first you sort the data by that value, then you go write data. So I'm just going to write set x by location. First start location, then so total balance is equal to 0, and then total balance plus what's the variable name, balance. So then you write if stop reading at if last start location and keep only location and total balance. Okay, sorry, total balance. So this would give me, so again, we all know this, but again, for our convenience, let's just run it. Oops, I did something wrong. Variable balance is running in slice. Okay, I must have missed them. I'm just, okay, now I run it by location, started it, now it must have worked. Okay, yeah. Now if you go here, this is the output we expected, new, right? So this is that by location, each location we have it. Okay. So again, in proc means, if you want to do it, so you go to proc means data is equal to X class location. So basically you would write sum here since you want sum, or class location, and where is balance, and then you go write output. Or if you can also produce output into output window, right? So I'm gonna write new one. So I'm gonna write drop underscore type underscore, and so since we wanted sum here, so I'm just gonna write sum is equal to total val. So this should give me let's write NWay because you do not want any output to be produced. So better you write a noprint statement so that the output would not be printed here, because you are more interested in getting the data into output data set. Okay. So, new one data set. Okay. So again, you can drop this frequency, so it will be same as the data step output. So the same way, so proc summary is same, right? Proc means and proc summary are same. Then write proc report. You go write proc report data is equal to X. So you define a class statement, a column statement. First you define location balance, then you write location, define location, and you write group by, then you define balance, and you write sum, and you run it. Okay. So you take the output into a data set here too. I'm just gonna call it new 2. You specify no print, it's required, it's not required. Okay, so just run it. So it will also do the same thing, right? It will produce output with only those location. New 2, if you go here again, you can drop this underscore break underscore, but yeah, this is same. Now if you want with proc tablet, you can go to proc tablet data is equal to X. So class, you specify location, you specify var, and you specify balance here, and there is a statement called tables. So the table statement will have location and balance. So you would specify it here. Okay. So again, since it is a tabular report, it'll produce the report in a different way, and you cannot take the output, but still it will give you the output. Okay, so the output is expected. So these many ways we produce it in SAS. Okay, now so that's why people again, this first.id concept and last.id concept, okay, it might sound interesting in SAS, but in SQL it's a lot easier. Okay, let's do the same thing. Okay, finding out the total balances in SQL, how it works. Okay, it will be a lot easier in SQL, and 99.99% people prefer it to write it in SQL itself in real time. Okay, so you write PROC SQL. I'm gonna write create new 3, select star comma. So first here you want to use these functions. Okay, sum of balance. Okay, so here the sum function will work column wise. Here it will work column wise like this. So you selected everything here, or let's just select only, since you want only location, I'm just going to select only location here. Location of sum comma balance as, I'm just going to write it as total val from X data set. So all you have to do is, first let's run it. So now sum function, what it is going to do, it is going to calculate the sum of this balance. Okay, so let's just run it, but you might find it weird here. You see here. Oh, sorry. So see now the total balance it must have taken. Okay, so by default, if you write sum of balance, sum of this variable name, it is going to take the entire data. Okay, 10,000, 2,000, 3, 4, 5. It is going to sum it. Okay, now since you want it by location, so since you want it by location, so all you have to do is add group by location. Add group by. So you use summary function, and whenever you want it by some location or any grouping variable or a class variable, you just write group by. So this, whenever you think of it, so think of this proc means procedure. Okay, so exactly you specify a class statement to specify that I want the balance sum of balance by this variable. So this is what you do it in SQL. Okay, so group by is a statement that will give you the location wise. Okay, so this output same as the previous ones. Okay, now here you can change this summary function, sum function to anything. Okay, here also if you want average in proc tablet or anything, you can just change it here. Of course, in first.id, last.id, it won't work because it only calculates the sums here. But here, anywhere if you change mean, it will work. So group by is a class that will group by a certain class variable and retrieve any summary. So in this case, I wrote summary. So remember, in data step versus SQL, the summary function, okay, the summary functions, how they work. Okay, so basically, in data step, if I go right, so I'm going to write total. So I write it here. So if you see here, in data step, basically the summary functions, okay, any of the summary functions you learn, mean, maximum, or anything, okay, they work observation wise, this way, observation wise, horizontally. So in order to use summary functions in data step, you're supposed to have multiple columns. Let's say if you have balance 1, balance 2, balance 3, balance 4, balance 5, this function will work if you have observation wise. But in my context, I wanted it column wise, okay, this way. I wanted column wise this way. So in SQL, the same functionality, when I use it, sum of the variable, so it works column wise. Okay, so this way, vertical versus horizontal. So this is what the output that I expected. Okay. Okay, so now if you see here, this output makes sense, right? So that's how, again, you have to remember this. Okay, some function in data step works observation wise, in SQL it works row wise. In SQL, again, both ways it works. It will work horizontally, it will work vertically. In data step it only works only horizontal. Remember, in data step it works only observation wise. In SQL it works, I can go here sum of balance comma 1 comma 2 comma 3 and specify, still it will work. All right, so this is something, again, please make sure you remember it, because these kind of concepts are very, very important. Okay, now okay, I have this data set, right? So now let's say I want to summarize the data, or let me simplify it. Okay, let's write it here so that it will be easy for us to understand. So now I have okay, now I have location and grade. Okay, so now I want to produce the summary by location and grade. Okay, so what does it mean is, So by each location and grade, what would be the balance? So you go write proc means data is equal to X. You write class. Since you have two columns here, you're gonna specify those. So again, you want sum, right? So you'll just write sum. So see here, so location wise, in CL location, you have grade A and the sum is 10,000. So in CL location, you have grade B and the sum is 22,000. Okay, so that's how you produce it. So in SAS, I mean in SQL, again, it's a lot easier. Since you want to summarize the data by two variables, so you're going to just specify location by location and grade, and you would just specify by location, comma, and grade. Now it will produce the summary by both location and grade. All right. So yeah, so this is how the group by function will work. Okay, group by function will work. All right. So and remember, so having state. So now again, we looked at all the classes. Okay, select from where group by having. Okay, sorry, having order by. So these are the classes we learned. Okay, so select basically selects it. So we know what does having do. So having basically filters the data from. So another thing. So having will always be used. Let's say after filtering it, I just want having. So the new variable total balance, if they are greater than 15,000. Okay, so you can use it. 15,000. Now it will work. It will basically filter out. So, oops. Oh, group by, yeah, greater than. See, it filtered out. So can I use where here? So run it. Does not work. Okay, so you must use having if you are using it. Okay, at the same time, you can also add where statement. Let's say where location not equal to or not equal to and why. Order by okay. So now, oh sorry. So again, everything ends with one set statement. Okay. Now if you see here, I used every statement, every class that will end. Okay. So I first wrote select and I used from where group by having order by. Okay. So this is the order. So where statement is basically filtering out anything other than location ny, and group by is basically summarizing by location and grade, and having is basically filtering out the data based on the summary functions you used, and order by is basically arranging the data total balance in descending order. Okay, so this is the complete the select class order. Okay, so you can use this. So again, I can remove any of the statement here. I mean, even if there's no rule that I should use all of them in one step. Okay, but if you have to have a condition where all of them to be together, this is how they have to be. Select from where group by having order by, all are one, and everything ends with only one semicolon. Okay, everything in select statement to order by statement ends in one semicolon. Okay, you can think of it as select as one statement. So all these classes or statements are part of select. So that's why it ends with semicolon. Unlike in SAS, where each and every statement ends with a semicolon.
Hey, Gangadhar. So it has to come in this order, right? Select.
Yes. Yeah.
Okay.
So it always has to be this order. When I say order, if there is a condition or if there is a requirement that is require you to use all this, you must specify them in order. Okay. But you cannot interchange them. So for example, I cannot write having first and then write group by. It won't work. Okay. Let's just try that. So if I change the class here, right? If I go right, having total balance and run it, look at the log, it produces syntax error. Okay. Because first group by, then having. Okay. It's you cannot interchange. Okay. Any of this, even if I write order by in the place of where, it is still going to throw an error. These have to be in order, the same order. So this is called select class order. All right. Now, okay. Yeah, so this is one of the mostly used concept. Okay, especially this group by concept is a very, very, very important concept. Okay, so that's why I would suggest you to go back and practice summarizing tables. Practice summarizing tables. So here I just use sum. Okay, you can always change it. Okay, if you want average also, you can average of each location, you can still do that. Okay, there is nothing because I have a condition that is greater than 15,000. So let me change it to 7,000. Okay, so see now. So this is how you need to practice it. Okay, I know it's past your time. Yeah, so practice only this particular component. I mean, everything is with an example, right? I mean, with the data step and this one. So it is more of a reiteration class for you. So you just have to, but this particular concept that we are talking now, using group by and having, this is used a lot. Okay, I mean, even if I have to pick between data step and these methods, I'll always pick SQL only because it's a lot convenient and it works faster compared, because in data step, I mean, in SAS, it's not that convenient there. So in SQL, people use it. Even in terms of writing, right, the code, it is easier. At the same time, these codes are, the SQL codes are universal. Okay, even somebody who doesn't have SQL, I mean, SAS knowledge can easily understand SQL, because if you have SQL knowledge, you will easily understand. So there are more people who understand SQL than SAS. So that's why people tend to write SQL queries more. Okay, so you can go ahead and practice these summarizing tables. Okay, so that it will help you a lot to remember this. All right. Yeah, so if you don't have any questions, I'll let you go and we'll catch up tomorrow. Thank you so much, guys.
Thank you.
Okay, so we all remember the concatenation in SAS, right? So concatenation is just concatenating two tables as it is. Okay, so for example, I have ID age. So I have 1, 2, 3, 27, 1, 2, 4, 28, run on data Y, input ID age. So 1, 2, 5, I'm because everybody is aware, right? So if I just want to concatenate, I'll just write set X, Y and run. Okay. So when I run this, so we all know that this is just a concatenation method. Okay. Whereas in, so this is just concatenation where you concatenate two tables. Okay. So in SQL, so this is how we do it in SAS. Okay. If you have more than one data set, you can just go specify X, Y, Z. It'll work, right? Whereas in SQL, this is how you do it. Okay. So PROC SQL, create table. I'm just gonna write final one as select. So first you select from a data set. So what is the data set we have here? X. Then so you have a statement called outer union corresponding. Then write select star from. Okay, so this is all. Okay, so your set statement here is nothing but your outer union corresponding. Okay, first let's just run it. So let's look at your work library. Oops, what happened? This failed. Why did I not run it? Oh, okay. I see. Okay, let me open a new session.
It says PROC IML is running.
Yeah, it's still running. Yeah. Okay, that's fine. Okay, let me restore the program. I don't want to lose it. Okay. Okay, so this worked. Now the same way, if I go here, okay, so if you see here, both the outputs are same, right? Let's go here. So this one I ran it with data step. Okay, so if you see here, final has 4 observations. So all it does is it just basically concatenate 2 data sets. So in SQL, so this particular command, outer union corresponding, will basically will work as a set statement. Okay, it will just concatenate these 2 statements. So only thing you have to do is you select statement and select the columns and first data set and use that set's outer union corresponding and select it. If you have a thought set here, if you have more than one data set, right, you specify Z here, whereas in here you would go right, outer union corresponding, and right, select star from Z. Let's say if you have Z. Okay, let's just create it, right, so it makes more sense. So 1, 2, 8, 29. Okay, so let's go look at final. So it has 5 observations. So your final one should have 5 observations. Okay, so yeah, this is equivalent to what you have here. Okay, so this is just a concatenation method. Okay, let me just put concatenation again. This method, no, people don't use it. So which one do you think easier, right? This data step is easier. Even the efficiency wise, right, this data step is easy. Again, I'm not talking about the efficiency between data step and SQL. Again, we'll eventually get to it, but yeah, syntax wise this is a lot easier. So even if you ask me, I prefer this one rather than this one. So that's why people don't prefer this one. The concatenation in data step is much faster than this one. The reason you learn later. Now the same way we talked about interleaving, I hope you remember interleaving. In interleaving, what happens, you want this entire 3 data sets to be arranged in an order. So what do you do in interleaving method? Basically, you sort out each data set. Proc sort data is equal to X. Let's say by ID you want to sort it. Proc sort data is equal to Y. By ID you want to sort it. Proc sort data is equal to Z. By ID you want to sort it. So now once everything is sorted, you're gonna say, let's say final set X, Y, Z by ID, run it. Okay, so this method is known as interleaving. This method is known as interleaving. So if you go here, so now we have all the IDs in order. So in SQL, it's all simple. Okay, again, all you have to do is just write order by at the end of the SQL statement. Okay, so the output you get here and this one both would be same. Okay, so this is interleaving. Now you can ask me which one is efficient, right? So this one is efficient. If you ask me, this one is efficient because You do not have to sort the data 3 times. All you are doing is you're just concatenating and doing it at the same time. Okay, so SAS doesn't have to go to 2 different steps and perform the concatenation. All right, so that's why this particular concatenation interleaving method is efficient in SAS. So that's why, okay, you don't have to worry. So interleaving method people don't use much in SAS. Interleaving method, because if obviously you want something in order, in real time mostly they'll pre-sort it and sort it. Okay, I mean after concatenating it they'll sort it, but not they do pre-sorting. The reason we talked about this interleaving concept is when you're trying to concatenate the data sets after sorting it, you have to remember when you have a large data sets, right? You have 50 GB, 50 GB, 50 GB of data sets, and your system doesn't have enough resources. Let's say your system has only 100 GB, but these data sets are itself 150 GB. In order to sort these data sets, 150 GB data sets, you need 450 GB data in your system. So those are the cases you'd use interleaving, or else even I never had to write a interleaving query in my real time. Okay, but it is just a concept you have to remember. The reason you have to learn it, because it is talking about SAS capacity. Okay, whenever you sort a data set, basically you require 3 times more space in your RAM. Okay, so if it doesn't, I mean in your disk, basically in real time, if it doesn't, it's going to fail. It's going to say that we do not have enough resources to sort the data. So that's why people basically when you want to concatenate, you break the data, you first sort the data, each data set, and then concatenate it. But yeah, this is interleaving the similar way in SAS and data step. Okay, now okay, now let's talk about operators in SQL. So again, these operators are different. Okay, these operators are different. So we have union, except, union, intercept, and except. Okay, so again, these we do not have in data step. Okay, these we do not have in data step. Okay, so these are unique and restricted to only to SAS. And again, these are very, very important one. Okay, returns unique values from 2 or more tables while concatenating. Okay, so so basically this also talks about concatenation, but this method isn't there in data step. Okay, for example, let's assume I have a data set with ID. Let's say I have name. Okay, so I have Mark 1, 2, 3, Mark 1, 2, 4, John, 1, 2, 5, Jane, B, ID, 1, 2, 3. I'm gonna say Mark 1, 2, 6. Okay, or let's just say 1, 2, 5 Jane. Okay, for our understanding. Okay, so let's assume I just want to concatenate. Just imagine I'm just going to call them day 1 data set and day 2 data set. So let's add some business context to it so that it will make more sense, right? So I have this data set. Let's assume I received it yesterday on the day 1, and I received this data set on the day 2. Okay. Now there is a question raised by the client or the business user saying that, okay, there might be some duplicates in yesterday's data and today's data. I mean, meaning we might have sent you the names or the people details again today too. So please make sure you eliminate those duplicates. Okay, so now if you look here, 1, 2, 3 Mark, it's there here and it's there here, right? So again, if you concatenate them, it's going to take the duplicates. But again, you can delete the duplicates. Okay, so but there is a concept called these operators, right? So I'm just gonna say final as select. Let me go to the new line so it will make more sense. Select start from day 1. So you just write union, select start from day 2. Okay. So it returns unique values from 2 or more tables while concatenating. Okay, so let's just run it now. So if you look here, final, see it concatenated, but it eliminated the duplicate. Okay, so if you see here, this 1, 2, 3 mark is gone, and this 1 to 5 Jane must have been gone. Okay, so total will have 1 to 3 mark, 1 to 4 Jan, and 1 to 6 Craig. That's what you will have. Oh, John, Jane also, right? So 1, 2, 3, 4, 1, 2, 5 Jane. We don't see any duplicates here, right? So everything is gone. So these 2 duplicates, Mark and Jane, 2 duplicates are gone. Okay, so that's how this union works. Okay, so this is a very interesting operator. Okay, because we do not have this facility in SAS. So this is the exact business context. Okay, let's say every day you receive a table, that's an Excel file, and every day you concatenate, and somebody comes and say there might be the repeated information which we already sent yesterday, and it could be available today too. So make sure you are not taking the yesterday. So such cases you can just use union, and this union exactly checks record by record. Okay, you do not have to do anything. You just put asterisk here. If you're putting asterisk, it checks by record. Okay, and picks them up. Okay, so there will be cases where let's say you have age here and you have gender here, right? Let's assume age 27. Let me copy it into a new one, right? So that it will be.
So this is like no dupe records, right?
Yes, exactly. That's what I was going to exactly say next. Okay, so this will work as a no dupe records. Yep. But that will in data step, right? The proc sort again has to be a different procedure. Here it is not, right? Here it is doing while concatenating itself. You see what I'm saying?
Yeah, right.
Yeah, so in SAS it works. I mean, the proc sort exactly works like this one, but only problem is there you have to first basically concatenate and then come back. Okay, whereas in here it automatically detects the observations. Okay, let's just see what happens if you have different columns, right? So in the previous case you have ID and name. ID name, it was easy. You just put asterisk here, select everything. It will be able to just take out the unique values. But 27, 28, 29. Okay, so you have it this way. See? So this is the error. So because you have 2 different variables, right? Age and gender, it's going to throw an error. Column 3 from the first contributor of union is not the same type as its counterpart from the second. The reason being, you have different columns, right? So such cases, if you just want, you have to make sure you select those values that you want. ID comma name, ID comma name. So this is the only way. If you have different variables, the union operator is not going to work. Now it must have worked. Okay, but only thing is you will lose those columns. But anyhow, it doesn't work. Okay, so the union works only with the common column names, because you should have, because you are checking by the record. I mean, how does it know that this record and this record are same, right? Because you have different variable there. So that's why you always have to have the common columns. Okay, so that's the union. Now let's look at the except operator or the intercept operator. Okay, so the intercept operator returns the intercept. Okay, the name itself says, right, returns common observations or records from 2 or more tables. Common observations or records from 2 or more tables. So what does that mean? Oops. So what does it mean is, so you go right, PROC SQL. Oh, you do not have to. I do not have to. So me go here, select everything. So what do you think we have common, right? So here 1 2 3 mark and 1 2 3 mark, 1 2 5 Jane and 1 2 5 Jane. So if I say intercept, it's just gonna return the common. See here. Oops. Something must have happened there. Oh, sorry. Did I say intercept? Sorry, intersect. Sorry. Yeah, I'm coming from R programming again. Okay, so that's what happens when you know too many programming languages. So it is intersect, not intercept. Sorry. Okay. Now write intersect and run it. Okay. Now look here. So it returned the common observations from records from 2 or more tables. Okay. You had 1 2 3 mark, 1 2 3 mark here, 1 2 4, 1 2 5 Jane, 1 2 5 Jane here. Okay, so that's why it returned the common values from both the tables. All right. Now,
like an inner join, right?
Yes. It's basically it is doing column by observation by observation, not the horizontal concept. It's not merging. It is basically concatenating. While concatenating, it is basically identifying which are saved in both the data sets.
Okay, yeah.
So that is intersect. So except is little tricky. So union is simple. Union basically eliminates the records. I mean duplicates and concatenate it. Whereas in except returns records only from first data set that those are not available in second data set or table. Okay, however you want to call it. Second data set. Okay, so this is again for our convenience. So what does that mean is, so it just looks at only this table. It just looks at this table and compares with the second table here and guesses, okay, what values I have only here but not here. So if you see here 1 2 3 mark, it is here but it is also here, so it will not consider this one. 1 2 4 John, it is here but it is not here, so it will be considered. So that's the definition. Okay, returns the records only from first data set that are not available in second data set. So 1 2 4 John is not available in second data set, so 1 2 4 John will be output. But 1 2 5 Jane, again it is here, but again it is here too, so it will not be taken. So only from this data set, first data set, it won't even consider the second data set. So if you see 1 to 6 Craig, though it is not there in the first data set, it will not be written because it is not there in the first data set. So it talks about always the first data set. So let's just go right except and let's just run it. Okay, so you ran it. Now let's go look at it. See, 1 to 4 Jan is the only value that is available in the first data set but not in the second data set. The rest of the data sets are available in the second data set, okay, at the table. And again, it is not restricted to only 2 tables. You can specify more than 2 tables, and if you have another one, you can if you have more than 2 tables, you can go right. Let's start from day 3. Okay, so you can always write it this way. Oops. Oh, we do not have day 3 here, so it is fine. Okay. Yeah. So those are the operators. Okay. So we looked at concatenation, we looked at interleaving, and we looked at these operators, set operators. We basically call them set operators. Set operators. Okay. But these are very not useful. I wouldn't say useful. Sorry. I wouldn't say useful, but yeah, one of the concept that is not there in the data set. Okay. Let me save it before I accidentally close it. Now, so okay, you guys are okay to continue for another 10 minutes?
Yeah, sure. For me, okay.
Okay. How about others? Okay. Thank you. Thank you, Nitin. Okay. Tony? Okay. Awesome. Thank you so much. Okay. So now, so we have to talk about joins. So again, this is the most important concept, right? Joins versus merge. So merging we already learned in data step, and SQL joins are in SQL. Joins are in SQL. Okay. So let's just see how does it work. Okay. How does it work? So we'll compare each and every merging technique that we learned in data step versus SQL. Okay, so the first rule in data step, right? First rule, what is the first rule of data step merging? First rule is all the data sets have to be sorted. Okay, SQL, no sorting required. Okay, so no sorting required. So you do not have to sort the data set. So this is one of the biggest advantages in SQL. Let me name it PROC SQL so that so you do not have to sort the data sets. Okay, the second one would be variable names. Let me say by variable names to be same. Renaming required if variable names are different. So let's imagine you all remember, right? We talked about this. Okay, so if you are merging two data sets, the by statement that requires you to have the data of the column names as same. Okay, if it is different, it's going to fail. So it says that that variable is not available. So that's when you basically rename the variables. So that's by variable names can be different. So you can have different names. No renaming required. So you do not have to rename the variables. So if you feel that, okay, I don't want to rename it, you don't have to rename it. Okay, but so if you have same, you can use it, but basically you can it can be different too. Okay, so by variable types have to be same. So let's assume you're trying to merge the data set by ID, customer ID or patient ID. In both the data sets you have three data sets. In the three data sets you are trying to merge, three data sets by variable has to be the same type. If it is numeric, across three data sets, it has to be the numeric variable. So if you have a different variable, type conversion is required. So let's say in one data set it is character, and in one data set it is different. So you have to go at least change one variable to either character or numeric. Okay. So by variable types have to be same, but no. Okay. Okay, so the by variable types have to be same. In data step, the type conversion is required. Here, they have to be same, but no type conversion is required. Okay, if you want to join two tables with a different by variables, you can still do it. Okay, and cannot join more than two tables without without common variable between the tables. So whenever I say table, remember I'm talking about data set. Okay. So what does that mean is this is a very, very important one. Okay. So this is where SQL stands out. Okay. This is where the SQL stands out. When I say that, okay, let's assume I have data X, and you have to remember this concept. Okay. I have ID age. Okay. 1, 2, 3, 27. Just some dummy data, random data. I'm just going to put here for understanding. So data Y, input, ID, location. Okay, 1, 2, 3. 1, 2, 3, LA, 1, 2, 5, CA, data Z. I have location, gender male, CA. Okay, so you have it this way. Okay, so can I merge these three data sets in a single step in data step? Can I merge these three data sets in a single step? No, we cannot in data step. Okay, in data step, we should have the common variable across all the data sets. Here you have X, Y, Z data set, but there is no common. There's no common variable. I mean, you have the X and Y data set, but the Z data set has a different column. Okay, so you cannot do merging. So in data step, what is going to typically happen? You have to first merge these two data sets by ID. You get the output. Whatever the output you get, you'll have location there. Then merge that the final output that has come from these two data sets with this one. Okay, that's always complicated, right? So you cannot really do this. But in SQL, so that is a flexibility. Okay, you can merge or you can join all these tables in single step. Okay, without having to going to a third step or second step. You can join all of this in one. Okay, so that's when it stands out. Okay, so can join more than two tables without common variable tables data sets. Okay, can join more than two tables without. So yeah, so these four are the major differences. Okay, so you have to remember them. And so before our class tomorrow, right, so you have to go back and I mean, again, if you have time or if you remember, this is totally fine. Okay, if you remember this concept, inner merge, outer merge, left merge, I'm pretty sure I talked about it, or right merge. So just go and talk about them. Okay, I mean, just go and just take a look at them. 5-10 minutes, that is fine. Okay, because the same concept we're going to talk about. Okay, because I'm going to compare these merge concepts again with the SQL concepts. So if you know this, again, you're going to find it a lot easier, or else it's going to I mean, if you feel that, okay, I had it somewhere but I don't remember, it's going to get complicated. Okay, so just a quick 5 minute even before the class, if you could join 5 minute, I mean 5 minutes before class, you just go over and look at what is inner merge, outer merge, and left merge and right merge. That'll be very useful. All right, I'd like to stop here because I know you guys been waiting for a very long time. And just I just want to check with you, is it okay if I just move 45 minutes back to our meeting this week, I mean for the rest of the week? Because I mean, I'm not sure about my schedule now. I don't want to say the regular timing and make you guys wait. I'm already feeling guilty. Okay, sure. Thank you, Tony. How about rest of you?
So what time you will start?
I'm in EST basically. My time is 9 o'clock. 45 minutes usually. 9:45.
9:45 for you is 6:45 for me. Okay, yeah, that's fine.
6:45 evening.
Yeah, I'm in the Pacific. Yeah.
Okay, sure. How about you, Nitya? Nitya?
I'm good actually.
Okay.
But how long will the class go on? Like usual 1.5 hours?
Yeah, same 1.5 hour. Yeah.
Okay. Okay.
Is there a problem if you go 1.5 hour? You can tell me, okay? Because I don't want you guys to, because my schedule is being now. It's supposed to end at 8:45, but it's being dragged forever. So.
No, it should be okay. I think it should be okay.
Vani garu, మీరు ఓకే కదండి? మీకు వచ్చి 6:30 కదా, 7:15. That will be fine, right?
7:15 or 50, sir?
7:15 అండి. 6:30 కదా మామూలుగా.
Okay, sir.
So yeah. Thank you so much. Yeah. So yeah, this week only. Okay. So next week again we can adjust. Okay. Because I'm not sure. Tomorrow I might be released early, but if not, I don't want you guys to make and wait for me. Yeah. Thank you so much, guys, and we'll catch up tomorrow. Thank you so much. Have a good rest of your day.
Yeah. Thank you.
Okay, so these concepts I believe you must have gone through. Okay, even if you don't, again, I'm just going to reiterate all of these concepts again one more time. Anyhow, we are going to compare, right? So SQL joins are again the merging in data step, right? But but there are some joins which are not available in data step. Okay, so we will look at them. So one of the first. So we have to look at these joins: simple join, cross join, and equi join. Okay, so these are the joins, a little different from what you learned here, the inner merge, outer merge. So first, let's complete them. Okay, simple join. Simple join, basically, it's a very simple one. Okay, simple join joins two or more tables and returns a Cartesian product. We'll see what is a Cartesian product meaning. Cartesian product is basically all the possible rows for each record. Okay, so remember the definition. It will be clear in a minute. Okay. Again, this is just a concept. Okay, you don't really get to use it. You get to use it, but again, you might never find such scenarios, especially if you are working in a project where it requires you to perform join between two tables, right? So I'm just going to create two tables here. Again, just pass some random data. So again, this concept, the simple join that we are talking about, it's not there in any of the in data step, it isn't available. Okay, so this is just in SQL. So the rest of them would be okay. So let's say I have this two data sets. Okay, one is X data set, another one is Y data set. So in X data set, I have 3 records, and in Y data set, I have 3 records. Okay. So what this simple join does is you just join these tables. Again, when I say join, you have to think of it as a merging. Okay. So where the horizontal side by side, merging of 2 data sets happen. Okay. So this by default nature of this simple join is when you join this table, each record from this table gets merged with each record of this table. So ideally, if you join these two based on one common column here, ID and ID, so your final output supposed to be 1, 2, 3, location LA, and the grade supposed to be A, because this record and this record is this ID and this ID is matching. Same goes with 124 CA. It has to be grade B. 125 CA. So 3 records totally has to be there, right? If you really join them. But let's just see what's going to happen if I write it. Okay? Create table XYZ, select. So first, so far, remember in select statement, whenever you looked at it, you are saying asterisk and selecting the tables, right? Here, you are going to select 2 tables in the same thing. Okay, so I'm just gonna call x dot star. I have to refer the data set name here, the table name. So I'm just calling it x dot asterisk or x dot asterisk. Because when I say x dot asterisk, I want everything from the x data set, x table, okay? Dot asterisk, every table, every column. And you just gonna put y dot asterisk, okay? So this is it. So you want everything from x. So that's the reason you specify x dot asterisk, all the columns, y dot asterisk, all the columns from both the tables, okay? Let's just run it. Oops. Sorry. So I missed from, okay? I remember from, oh, what things? Oh, sorry. Okay, so in select statement, basically, I would write the columns that I want. So in this case, I just wanted all the columns from X table. So it understands that X table, since it looks at from statement and understands that you want all the columns from X table, and it looks at Y, so it has to be separated. So the select statement selects both the data set columns from both and XY tables. Okay, so this is known as a simple join. Okay, because you're not specifying any condition here, you are just running them. Okay, now look at the log. So it says variable ID already exists because you have ID in both the tables. So it always picks from the first table. That you can ignore. So if you look here, so each record, so see each record here. So 3 into 3. So each record here, see 1, 2, 3 is repeated 3 times. 1, 2, 4 is repeated 3 times. 1, 2, 5 repeated 3 times. So what is happening here? All the possible rows for each record from the first table. Okay, when I say first table, so all it is doing is it picks up each record and joins it with the second table. So let's say you have 4 records here. Now from the first table, so this record gets merged with this record 3 times. 1, 2, 3, 4. So here again, this one, sorry, 3 times each record because 3 records you have here. So fourth one also, though if you look at here, 126 LA, this is entirely a different ID, but still it gets merged, joined with this record in this table, and each row will be written. So total 1 into 3, 4 into 3. So total 12 records will be there in the data set. See now? So if I have another one here, let's say I have 127 D grade. Now run it. So you have to think of, if you are performing a simple join, it's always the number of records here into multiplied by the number of records here. Okay, so it's 4 into 4 here now. So you'll have 16 combinations here. So likewise, okay, so all you have to do is select the table name, and the asterisk stands for all the columns, and again y dot asterisk from all the columns from X and A, Y. Okay, so what are the tables you have? So this can also be written this way. This is very important. Okay, not this concept, but the way we write it. Okay, so there will be cases where if you feel that specifying this X and Y data sets becomes tricky. Okay, for example, so when what cases it will become tricky? Let's assume. Let's say you have file for location. The data set name is file for location, and this data set is file for grade. Now, if you feel that writing this file for location, and so again, if I have to refer those tables, so I have to go write file for location, and I have to write a file for grade here, and the same thing here too, file for location and file for grade. So it is just based on the data set names, right? So it will work fine, but the problem is, you are, it's always gets complicated. Okay, specifying the table name always becomes complicated. So that's those cases. So in this case, it was easy because I specified X and Y. The data set name is just one character. But in these kind of cases, if you feel that it's going to be difficult one, you can just refer them as A and B or any other name you want to choose, any character. And while you are calling them, you can call them with those names, okay, alias names. So now, instead of specifying the table name like X and Y here, the original table names, you can choose an alternative or alias name for those table too. So when I say A dot asterisk, now SAS has to understand what is that A dot asterisk, right? So it goes and looks at from statement and sees that you define file for location table as A. So it understands that whenever you refer A, basically you meant this particular table. So it just takes all the columns and pastes them here. So the same case, B dot asterisk when you said, so it understands B is nothing but this data set. So it just picks it up from everything, okay? Now, run it. So it must have produced the same output as this one, okay? But you have to remember this, okay? In real time, you tend to write this way, okay? Instead of writing the data set name, because the data set name can be larger or it can be complicated one. So every time specifying the table name and specifying the column, it will be a complicated one, okay? So let's assume you performed a cross join, right? I mean, simple join here. So in simple join, let's assume there is an additional column here. Let's say salary. Additional column for salary. We have 7,000, 8,000, 9,000, 10,000. Okay. So if I write asterisk here, now we know that asterisk basically stands for everything from the table. Okay. If I go here, you would see salary 2 joined with each row in the second. So there will be cases where you do not want salary to be selected. Okay. You want everything to be selected from this table. But so in select statement, you can always control them. Okay. There is no rule that you should always write asterisk. So you go right XYZ as select. So let's assume since your table A dot ID, X dot ID, comma, X dot location, Y dot ID, Y dot grade. So I just wanted this, or I want everything from Y table. You can just say Y dot asterisk from X, comma, Y. So this is how. So now I do not want to select the salary column from the X, so I could control it. Okay. Again, not in this context, they really matter, but you have to remember whenever you specify the table name and asterisk, basically it selects everything. So you can write it for everything. Okay. That asterisk, right? You can always write it for everything. So again, just to go back a little, so remember we learned this methodology, right? Select, let's say I want to select names X age from SAS dot class. Wait, so it works here, but there is nothing wrong. Again, you can also write this way, dot name or A dot sex, A dot age, so as A. So you can write it this way too. So again, you don't do that, right? Because it is just one table. You really do not have to rename this table as alias and put A dot name and A dot whatever. But yeah, this way people write it, because like I said, whenever the data set names are complex, so instead of specifying the data set name every time, people tend to just refer them with as and use those alias references here. Okay. Yeah. So that's the concept of the simple join, where it joins two or more. If you have more than one table also, it will be the same thing. Okay. Let's just assume Let's go back here. We basically looked at only 2 tables here. Even if you have more than 2 tables, so you can go right data Z input. Let's say it doesn't even have to be an ID. Or let's say ID. What do we call them? 1, 6. Now you can go right PROC SQL, create table, new 3 as select X star asterisk, everything from the X table, everything from the Y table, everything from the Z table. Okay, now I'm selecting the third table too from X comma Y comma Z. So I selected everything from these 3 tables. So again, it is going to be a Cartesian product. See now? So you have 48 records now. So if you go here, 4 into 3 into, so each record gets, each one gets merged based on the first table. Okay, so that's how it entirely works. Okay, again, like I said, this isn't, if you look at it, it might look silly, but again, I can't really say that you might have a requirement where you want each and every record to be a map with 1 record at a time. Okay, so that cases it might matter. Okay, so what kind of cases I'll tell you. Okay, I can just give you one example. For example, you have, let's say, ID. Let's just say you have ID. You do not have anything else. 1, 2, 3. 1, 2, 4. You have only 2 records. You have input. Let's not even have ID, right? Okay, let's assume, just to give one simple example, right? So these cases, let's say everybody from the table X belong to location Y. So I just want this table value to be masked. Okay, because again, tomorrow the value might be changed, but I still want every value to be changed. Okay, so I can just go right X comma Y and run it. So now each record from this table gets merged with this record. See now? So this kind of cases, right, where you know that each and every value has to be matched with this one. So those cases, it will be easier. Yes, Srinivas. Yeah, wrong joins also we see Cartesian results, correct. So yeah, so that's the simple join. We have cross join, which will produce the similar result as this one, the Cartesian product, a simple join. If I go here, so again, so all you have to do is, so this is where you specify a command first time. So you can from X. Okay, let me write it. So the cross join is, again, it's a statement. Basically, you have to use it. So new for as select. So you select, again, you select everything from X and you select everything from Y. From X, you just specify cross join it with Y. Okay, again, there would be no condition. Let's just run it. You're cross joining it. So the cross join also will do the same thing as the simple join. Okay, so only thing is here, your statement called cross join exists. So it cross joins each and every record from the first table with the second table. Okay, so that's cross join. Again, another simple join form. And this Equi join, again, it's very important. Equi join, though, this you would easily understand. Okay, so returns Equi join, returns common records from 2 or more tables. Okay, so it records only the common records. By this time, when I say common records, you must have understood that in data step we have this method. But again, let's just look at it. Okay. So let's just assume now, just like join, I just want to join these two tables. Now I want my data to be this, okay, ID, location, and I'm supposed to, I want to have grade, and location supposed to be LA for 1, 2, 3, 1, 2, 4, CA, B, 1, 2, 5, CA, and C. So in data step, what step, okay, what kind of method will produce me this result? If I want this output, what should I write? Which methodology I should use to produce this output? Oh, sorry, the last one supposed to be 1, 2, 5.
Only using data step or any other step?
Yeah, data step.
Just the data step. Okay.
Yep.
So we have ID, grade. Okay. We can merge.
We have to think it from merging perspective.
Yeah, we can merge the data, but what I'm thinking to remove the duplicate, maybe I might use a PROC, no duplicate on the ID. That's what I'm thinking.
Mm-hmm.
Merge data X with data Y by ID and PROC sort on that one.
Mm-hmm. Yeah. So basically we perform inner merge there. Okay. So we first go sort the data sets. PROC sort data is equal to X by ID. So we all remember this, right? So the data sets have to be sorted always. In this case, you don't have to, but you have to get used to it, because in real time, you don't know when you receive data set, the data set will not be in order. So final, so merge, again, I'm writing it so you can make sure you understand this. ID, if X is equal to 1 and Y is equal to 1. So this one everybody understands, right?
Yeah.
Yeah. So this is nothing but inner merge we talked about. Okay. So basically, it just returns. Oh, something happened.
X is uninitialized. Okay.
Oh, sorry. I said Y
equal to 1.
Yeah. No. I said A and B here. I aliases A and B, but I used X and Y. So that's the reason. But it must have worked. So now, so this output, right? So this output again. In SQL, it's a lot simpler, not simpler. Again, you have to remember the syntax. Create table, XYZ, you write. First, again, go select A dot star, comma, B dot star from, you write your X as A data set, comma, Y as B. Okay, you selected everything. So if I run this one, so what happens again? This will become a Cartesian product, right? If I run this will become a Cartesian product. Okay. So instead of that, you can specify saying that I want IDs to be matching. I want rows to be returned based on where the first ID and second ID are matching. So here, you know that each and every value is matching, right? Now, if I go run it, so you would see the output, which is similar to the previous one, okay, the data step one. This output and this output would be the same. So this is basically known as an Equi join. The reason it is called Equi join, because you use it with a where statement. This symbol basically, it only returns where these are common records, common by column values from both the tables. So hence the name Equi join, and you can also join more than two tables, and it always returns only the common values. It always returns only the common values. Okay, so the common ID values. Okay.
Why you go for A and B instead of directly going in X and Y?
Yeah, we can go. I just wrote it. You can always go. That's a good observation, right? You can go X and Y, and you remove this. You do not need these aliases. Make sense now? Sorry. Yeah, you can write this way too. But I just wanted to give you a different perspective on this. So yeah, so always get used to this methodologies, especially in joining. There is no way you have to refer. I mean, you can write the data set name and select it, but it always gets complicated. So should be thorough with this one.
When because of longer names, table
Yes,
names.
yes, exactly. Okay. Now, so that's Equi join, and you can always join more than 2 tables, right? Let's assume, did we bring in another table? Okay. So I'm just bringing in another table here, XYZ. Another thing, if you observe, the first condition I mentioned, remember, in SQL, no sorting required. Even if you see, I did not do any sorting here. So I just joined them. Okay. So that is something again you have to remember. For any of the SQL joins, you do not have to sort the data. So whereas in data step, we already have seen, right? If you don't sort the data, in this case, it works because everything is in sorted order. But if you don't sort the data, it produces an error saying that variables are not properly sorted. Whereas in SQL, it doesn't throw any error. Okay. If you want to check for yourself. Let me
so in real time, mostly you'll be using SQL, right, for joining?
Yes, yes. Again, we cannot undermine data step 2. There will be cases where you would also prefer data step. I mean, again, nobody's going to stop you if you're writing in data step.
No, I'm just saying based on the size of the data, right?
Yes. Yeah. If you have larger data set, SQL join is always the right choice to do.
Okay.
Okay, so let's see what happens. I mean, again, if we do not sort the data, right? So let's assume I have 127 CA. Here I have 127. Oops. 7A, 127 CA. If I don't sort the data and I still try to merge them, Now let's see. See, by variables are not properly sorted on data set. Okay, so that's the error you get. Whereas in SQL, you go and run it with the same Equi join I'm running. Get the log, so there is no error. Okay, so still that join must have happened. Okay, so there will be no issue. So yeah, so that's something again you have to remember.
But it's not sorted in the data, right? In the SQL one.
No, it's not. It produces in the same way again, the same order.
But the 127 is on the top, right? So correct. It's not sorted.
It doesn't sort it, and it does not require you to sort it. Okay, so again, if you were actually, that's a good observation, right? So again, if you want your data to be sorted, again you have to add an order by statement. So in data step, by default, the data will be sorted order because you pre-sort them.
Gangadhar, see, it's more like for merging, it's need to be sorted. So that's how it understands. SAS understands the data, right? Record by record.
Mm-hmm.
But in PROC SQL, it's nothing to do with anything. Sorting is for your convenience, right? More like. But when SAS, it's a mandatory because it's sort by record.
Correct. So it's just functionality. Yeah.
Yeah.
I don't know. In real time, how does it? They need sorting or just they join it? You can just join it.
So let's assume you have million records. How do you sort it? Right? You won't check for record by record, right? You want to pull any record, you just sort by the record number, right?
Filter.
I don't know. I'm just asking.
I'm just for your question, I'm just giving an answer saying that okay, let's say you pulled a million records. So Srinivas ID is there. So sorting really doesn't help there, right? You only pick Srinivas by some condition, where ID equal to 1, 2, 3, which pulls Srinivas ID, right? But here, what Gangadhar is saying is that it's a functionality for data step.
No, I understand that part. I'm just asking in real time whether you need sorting or you don't need sorting. That's it.
Okay. Again, it's both ways, right? If your business requirement is to have top records, based on.
Yeah, I mean, understand your point. Like you can go and select whatever you want. instead of sorting. Yeah.
Sorting really doesn't require, but again, sometimes if you're doing summarized data or you're doing some kind of aggregated functions, right? Maybe salaries and all, maybe that might be a case where you want to pull the maximum 10 employees, something like that. Probably that might be a case where, order by descending or ascending. Yeah.
So in your data step, you will always have to sort, right? To get a merge to work correctly. It's not something that you do just out of convenience. It's a requirement for data step programming. As a programmer, there will be situations where you want to pre-sort things, not just because you want to merge them, but because equally, you may need to get rid of duplicates. You may need to isolate a subset and pull out just a certain category of variables or whatever that you need to be able to merge it in. And so it's not just for convenience. There's also the added benefit that you may need to maybe, get just maybe unique subject IDs or unique, employee IDs or whatever it is that you want. Then you bring it to merge it with something else. So yeah, you need it, number one, for data, for your data step processing, and then number two, sometimes you need it for subsetting purposes. But in SQL, you don't necessarily need to sort. But then if you still have that same purpose that you want to maybe identify just employee IDs or just a certain criteria, then you'd have to decide how to do it within SQL and then still, perform your join. If that helps. I hope it didn't make it more complicated.
Yep, perfect. Yep, that's what it is. Yep.
Okay.
Yeah, good stuff. Yeah, it is so satisfying to see you guys discuss. Yeah. Thank you, Tony, and thank you, Srinivas. Thank you, Srinivas. Okay. What happened? Yeah. So in SQL, right? To answer Shenmugam's question, yeah, it's always the context. Okay. I mean, if you're joining with SQL, if somebody says that, okay, we might need this data in order, you can always use an order by at the end, and you can always sort the data. Yeah. Vani, yeah, she's a curious listener, I guess. Oh, let me figure this out. What happened? Oh, sorry. Yeah. So that's with the what do you call the Equi join? Okay. You can always try it. So once you're done with this class, you can just go and create your own 3 tables and practice with them and understand. I mean, you always run into something, right? So the types or anything. Okay. So another thing I just want to cover here. Again, the second one, when you're joining, right? When you're joining any of the tables, okay? So in data step, again, let's assume in one data set, you have one data set has ID as character, another data set ID as numeric, okay? So even if you sort these data sets and you try to merge them using data step, so it's always going to produce an error. So the reason being, the variable types are different. The reason being the variable types are different, okay? But when it comes to SQL, it will still have the same issue. Let me go run it, right? So that you'll have understand. Create table, XYZ, select. So I'm just going to select X comma everything, Y comma everything, from X comma Y, where when I write X dot ID is equal to Y dot ID, it is too going to produce an error. Okay, so expression using equals as components that are of different types. So that's when I mentioned, if you go to the context I gave, right? I mean, the definition I gave, the differences, Bivariable types have to be same in data step. Type conversion is required. Bivariable types have to be same. No additional programming is required. So which means you do not have to go and write, basically you do not have to do type conversion here. So all you have to do is, so which one? So let's assume this you want it as a numeric variable, right? So while joining itself, you can use the input function or put function, okay? Either way, either vice versa, right? You can convert that into character. So you can write this way. Now what's going?
Yeah. So when we create any kind of large tables, right? So I'm calling tables. The reason behind, when the table is being updated on daily basis, over the time, when the table gets aged, right, it will be like holding millions of records. So what database guys does, right? So they set all kind of triggers, as well as when we create a table, we set up all the indexes on the table. So that will giving a very fast retrieval, right? So you go directly to that one. So these are the things which we take backend, but as a developer, we may not know, right? So even though it's a million records table, but when you're doing your conditioning, you're just getting the record just like that based on the databases, right? So that's what one of the things sometimes help you out, right? Okay. So yeah. But again, this is more like an administrative stuff. This is nothing to do with our stuff, but you might think like how the data is coming so quickly for some of the systems like Teradata or Netezza or something. When you take Oracle has a lot of these issues, right? So they set up all these things backend. They set up all kind of functionalities on the data tables, and we know, right, pretty much like this table, this is a let's say transactional table, and we know next 1 year this table will be growing, right? And it will be holding much data, and sometimes we might hold 10 years of historical data as well. But I'm talking in financial sector. But in healthcare, it will be more like an updated records for them, at least 5 years of data they might handle. But yeah, that's what it is.
Okay.
All right, good stuff. Okay, so yeah, so when you're joining two tables, right, if one of the columns you have has a different data type, you unlike in SAS, right, where you go to a different step and you use input function, create a new variable, then drop it, rename it, and totally you'll have a new data set, and then come back here and merge them. Instead of that, you can just use input statement. While joining itself, you can just perform the join. Okay, now while joining itself, the type conversion will happen on the join, but not on the table. So there will be no changes on the output, but only the while joining itself, it will just convert everything in the memory and joins it with this particular column. Okay, so this is again an important concept you have to remember. Okay, because time to time you might encounter you are joining two tables, and in one table the column has a numeric type, in another one it has a character type, or vice versa, right? So you can just utilize this functionality and join them. Okay, so so those with the joins, right? So this is basically Equi join and Equi join, and you can join more than two tables with it too. Now let's go to our
Gangadhar. So what if one of them is numeric, one of them is character? Because you are putting the whole X, right? Because one of them is character there.
Whole X meaning?
I mean where input X, right? You're converting all into numeric, right?
No, it doesn't actually convert. It only matches with those by converting them in the backend. So let's assume this 1, 2, 3 is a character one. This 1, 2, 3 is a numeric one, right?
Okay.
This is a character. Let's say this is numeric. But in data step, it won't happen. It will produce an error saying that this is character and this is numeric. In SQL, what happens? When you write input function, it does not change in the data set only for that particular column. It just changes the values for the joining purpose. That's it. Only while joining, it just converts these values and maps it, and just for mapping purpose. It doesn't even produce the output.
Okay.
Now let's go look at the inner join. Again, the not inner join. Okay, let's look at the full join first. So the full join, again in data step. I must have talked about a concept called full merge. So So let's, for the same thing, right? Here, I think we already have the data in place, so it will be a lot easier. By ID run. So data is equal to y by ID run. Okay, so you have to tell me what would be the output here. So if I write merge x y by ID, so what will happen here if I just merge this two tables? What would be the output? So this is the program. So I'm just writing, I sorted the data sets. If I run it, what would be the output? So this is known as a full merge. Okay, if you remember, I called it a full merge.
We get all the records, right? So basically all the records from both the data sets.
Correct. So it returns all the records from both the tables. Okay. So that's the full join concept, right? So similarly, so again, let me just run it. Now, if you see here, 127 CA, it will have 127 A, 123. So the 126 will be missing because it is not there in the second data. So it returns all the records from whether they are matching or not matching from the both the tables. Right. Whereas in, so let's run it, right, for our understanding. So let's go here. Oh, must have produced an error. Guessed it. Oh, again, sorry. Okay, so this is the output, right? So in SQL, let's see how do we write it. Okay, so PROC SQL, again, you already know. Only thing you are going to learn a little differently. So final, this is same, and you want to write as. You can refer the tables here, x dot star asterisk, or if you dot y dot asterisk, this will remain same from x. So this is where instead of we are not performing equi join here, we are performing a full join. So instead of the comma, you have to separate it by a statement called full join. Y on which column you have to specify? On x dot id is equal to y dot id. And x dot id is equal to y dot id. So when you run this one, now it has to be the same output as the previous one. So if you go here, same amount of records, 5 records, and this output, the data step output, and this output is same. Okay, so the full join returns. Here you do not have to specify full join. By specifying by ID itself, it gets everything. Okay, whereas in here you have to specify full join that in order to produce a similar output. Okay, full join gets you all the possible records from both the tables. So like again, I'm being a broken record here. You can always go and convert them as aliases. Okay, x as a, y as a dot id, b dot id, and real time. Again, this is my personal choice. Okay, again, you do not have to follow this. If you want your code to more readable format, right? I would always prefer to write it this way instead of putting, especially in SQL, because you use multiple statements in SQL. It always gets complicated. So I tend to write this way. Okay, again, there is no rule like this you have to write, but I prefer to write it this way so that it will be a lot easier for me to read it in, so one by one. So even if I'm getting used to it, again, it's for my own purpose. I tend to write this because we don't always remember what we write, right? So if I write this after 1 year, after 1 year, I need no chance that I have written this and I would remember this logic. Okay, so but for my convenience and for others' convenience also, if I write it this way, it will be pretty simple. Okay, A table, B table, from these joining on table, so you can just quickly scan it and easily understand. Here, if you have everything in one line, it will always be confusing. Okay, because again, this is just a simple one. Okay, in real time, you'll have a larger query, so it will be a lot complicated one. Okay, so run this one. Again, we did not change anything, right? We just formatted the code. Oops.
Y as B?
Oops, correct. Good catch. Yeah, Y as B. Now it must have worked. Okay. And so, yeah, again, it's your wish. Okay. If you feel that you understand the way you write it, but I tend to always write this, especially SQL joins. They look more clear and understandable and readable. So another thing, if you observe, there is a warning that says here, right? Variable ID already exists on work.final. So what does it mean is, whenever you say asterisk here, a dot asterisk, so what does it mean is everything from a table. So what is the a table here? The a table is the X. So in X you have ID, and the same way you are selecting b dot asterisk. Okay, so b dot asterisk from the B table also you're selecting everything. Again, in B table also you have ID, right? So basically it will be your table, so this is how your code gets converted. This is how our code gets converted. So again, I'm just writing converted. This is how it gets converted. Okay, so it goes like a dot ID, a dot location, b dot ID, and b dot. So this is how your code gets converted in the backend. Okay, when you submit this code, basically SAS converts that statement to this way. So that's why if you see a dot ID and b dot ID, so you are referring ID twice. So now SAS first takes this ID to the data set. The output, whatever the ID you see in the output, right? This will always coming from the first data set you referred here from after from. So that ID variable or whatever the joining variable you get is always from the first table. Now what happened? Since it is already taken ID, now you are basically specifying b dot ID again. So that's why it says that variable ID already exists, because it has already taken here, so it won't take here. So that's why it produces warning. Again, it's not an error. So to avoid that error, so instead of specifying asterisk here, you can specify the column that you want. Okay, in this case, I just wanted b dot grade, because anyhow ID is taken from this table and I'm matching them anyway. So you just write and run it. See, now that warning is gone. Okay, so this is how you write full join, and in SAS full join, and there is a concept called full outer join. It will also produce the same output. Okay, even if I specify full join or full outer join, it will have the same output here. Okay, so you have to remember, in the place of where, I'm specifying on. Okay, where if you specify, that will become an equi join. Remember, where if you specify, that will become a equi join, and you do not need this full join. Okay, so whenever you specify this full join, you must use on, and you have to remember the order. Okay, it's always the first table and your operator, joining operator. In this case, I specified full join, and then the second table, and then the condition. Okay, in this case, I had only one variable. Okay, so what happens if I have multiple variables? Just let's look at it. Okay, again, I'm just going to create two simple data sets. Okay, let's not complicate this, because you already know what does that merging do, whatever, right? So ID age 1 to 3 27 1 to 4 28 data y input just want to specify. Let's go this way. Next one. Okay, if I run this one, what's going to happen? If I join these two tables, right? PROC data is equal to X by ID. I just want to merge it by two tables now, by the age, and run PROC data is equal to Y by ID age, and run data final merge X Y by ID and age. So what will be the output if I run this? I see a ping. So, Srinivas, we wanted to have 1.5-hour session. Okay, we thought you were okay with it too. I saw your email. Okay, you have a hard stop at right now.
So so right now I was in the Central Time. So right now it's 9:45 for me.
Oh, okay, sure. And then yeah, we'll. I mean, I'll close it again. We can catch up tomorrow. That's fine.
No, that's fine. So is this for this week or like?
Yeah, for this week. For this week, yeah.
That's fine. I can catch up with the recordings. That's fine with me. So only for next 2 days, right?
Yeah.
Okay. I'll stop by 9:45. That's okay.
Okay, sure. Okay, so what output it will produce, this particular one?
I was looking for merging based on ID and age. Okay. I think we'll get all the records, but whatever populated will be populated for only ID and age. That's what I'm thinking.
So since we are joining by ID and age, right? So 1, 2, 3, 27, this matches. So this 1, 2, 4, 28 will have location missing, and this 1, 2, 4, 29 will have salary missing, right? Yeah. So you joined it by multiple columns here. Okay, so even in SQL, if you want, again, I just want to show you the syntax. Okay, the concept I just tested, if you all remember it. So select x dot asterisk y dot asterisk from x, full join. I want to full join it with y, and a dot id is equal, x dot id is equal to y dot id. And so far, I mean, just like here, you have two columns. You specified them in the by statement. Here, if you have more than one column, you have to use an AND operator and specify x dot age is equal to y dot age. X dot age is equal to y dot age. Okay, now let's just run it. Okay, now it produces the same output as the previous one. Okay, I don't think we have seen the previous one, right? Accidentally ran the entire thing. Okay, so here you have it this way, right? So 1, 2, 4, again, and this we pretty much understood. Now, here if you observe, oh, sorry. Okay, so here, if you see, the second observation went missing. Okay, the reason being, so the 1, 2, 4, right? 1, 2, 4, 28. Okay, so again, you are trying to match it by both X table and Y table. Okay, let's not make it complicated here. Okay, let's just do this. Now I just made sure everything has the same number. Okay. Now if you go here, the final data set, so we'll have everything, even the salary. Let's not produce the same. Sorry. Okay, let's not complicate it. Okay, so here I just joined two of them using ID and age from both the tables. So it just checks by ID and age in both the records. It is same. Okay, in SQL, this is how you have to write it. Okay, you are basically checking by both ID and age. So just like by ID age here, you use here it has to be. You have to use an AND operator and specify the second condition. Okay, if you have more than two variables here, let's say you have another variable, you just specify another variable in the by statement. Whereas in here, you have to go and specify another variable using and. If you have 10 variables, you have to specify 10 different AND conditions and run it. Okay, so this is how the full join works in SAS. This is how full join works in SAS. Now, the similar way. So again, you have to remember this. Okay, again, I'm not going to repeat it no, because I do not want to complicate too much. I do not want age here. I just want to remove it. ID and salary. ID and location. Okay. So this is a question for you. Again, one question. So PROC. I don't need PROC. Data Z. Merge X and Y by ID. So if I run this, so what will be the outcome? Sorry. It's equal to A. Is equal to A. And in is equal to B. Okay, so if I run this, okay, what would be the output? If I run this, what would be the output? Oh, sorry, my bad. What would be the output here?
None.
No, what IDs are matching, right? 1 2 3 1 2 4.
But there is no common, right? Other than ID.
Yeah, I used by ID here.
Oh, ID. Okay.
So so if we go look at it, so you'll have two observations because IDs are matching 1 2 3 and 1 2 4. So this and these are matching. Yep. Okay, so no, 1 to 4 is also that one. So both by ID you are matching. So this is called inner merge, remember? So we call them inner merge in SAS, okay, data step. So if you want the common values in SQL 2, so you would go write PROC SQL create table new as select X asterisk comma Y asterisk from X inner join. Okay, inner join Y on X dot ID is equal to Y dot ID. So this is what you'd use in SQL. Okay, so if I go look at it, see this output and this output would be same. So you want the common observation between the two tables, so you'd use inner join. You'd use inner join. Okay. Yep. Perfect. Correct, Tony. Yeah. So yeah. So this and this is same. All right. Now we have left join, which is the mostly used join in real time, and right join. But again, I'll stop it here because that will become too much information. But remember, left join is the join that is used. Yeah. Intersection of two. Yep. So left join and right join, left join again. Left join is a mostly and frequently used join. Okay, so that's why you need to be a little careful while learning this concept. Again, it has to come from the business context too. So that's why I'm just going to give you some time to get back to this concepts and practice them. Okay, again, you're not learning anything new here. You already learned this concept in data step. The concept was merging. I know everybody knows it. Okay, I'm just reiterating. Right? You're not learning anything. Okay, the SQL joins are more flexible because you do not have to sort the data, and you do not have to worry about renaming the variables, and you do not have to worry about changing the data types. All right. So yeah, so that's the inner merge and inner join. So tomorrow we'll cover left join and right join, and we have subqueries. And some of the data step versus SAS versus SQL functionality. Okay, SAS versus SQL functions. Some of the functions we will see. That's it. So that with that will be done with SQL. Then we'll move on to the macros. Okay, but make sure you spend some time practicing it. Okay, I don't know from your side. Again, you might find it difficult. If you find it difficult, it's not difficult actually. If all you have to do is just practice them. Okay, just like how you did data step. And if you feel it is easy, again, it is not easy because it might look like easy unless you practice them and you start writing your own queries. It's not going to be easy. All right. Yeah. So with this, I'll stop. If you don't have any questions, I'll see you tomorrow. Okay. And make sure, please, you practice this. All right. Yeah. Thanks everyone.
Hey Gangadhar, just for tomorrow, can you give an example for renaming? Because you said you can join without renaming, right?
Yeah, yeah, we'll talk about it. Yeah.
Okay.
I just realized. Yep.
Okay, thank you.
Yeah. Yeah, I just started it. Yeah, thanks. So left join in SQL versus data step. Okay, how does it work? Let's see. I'm just going to create one data set. Okay, so I'm just going to create one data set here, sample data sets for our understanding. So okay, so in left merge, right? So in SAS, basically the left merge. I hope you guys remember. So the first rule of merging is, let's go sort the data, both the data sets. Okay, I sorted the data set. Now what I'm doing is I'm just going to perform a merge. This in is equal to A. So everybody remembers in option, right? So it basically creates two automatic variables. So if I go say if A, so this will become our left merge, okay, or left join in data step. Okay, so what does it mean? So basically it returns all the rows from left data set and goes and matches with the right data set, whatever the values that are available. So in this case, 1, 2, 3, 27. So 1, 2, 3, because we are merging it by ID. So this 1, 2, 3 and this 1, 2, 3, both are same. So it merges with this 1, 2, 3 and returns location LA. So your final output would be 1, 2, 3, 27 location LA. 1, 2, 4, it matches here. So your final output would be 1, 2, 4, 28 and CA. But 1, 2, 5 is not available in the second data set. So it will be 1, 2, 5, 29. The location will be missing. Okay, let's just run it. So that's the output we are expecting. Okay, see here. So this is the output that has come from data step. So you have to remember, it returns all the rows from left data set and tries to match it with the right data set. If it has, it will return the value. If else, it will just return the missing value for the corresponding variable that we are trying to bring in. In this case, that is location. Okay, now let's see what do we do in the SQL, right? So as usual, so this will remain same, create table XYZ. Let's just create final one. Select. So I'm going to select everything from X table, then I'm going to select everything from Y table. From X, you're going to write left join the Y data set on which column you need to specify, on A dot ID, comma B dot ID, and quit and run it. Okay, so this is this simple. Okay, let's just run it. Oops, see, rookie mistake. Okay, so X dot ID, Y dot ID, instead of that I wrote A dot B dot ID. Okay, so now if you look at the output, it's supposed to have the same output as data step matching. Okay, see, this output we had through SQL and this output we had through data step. Okay, so this is just one simple example. Okay, let's look at let's make it more complicated. Okay, so I'll give you more complicated example now what happens in real time. So let's just assume I have these two tables. So I have grade here, grade A, so grade B. Okay, now here my matching variable, okay, the by variable that I'm supposed to use are ID and age. Okay, let's just say ID and age are my matching variables. So if I execute it, just take a look at it. What would be the output if I perform a left merge in data step, or if I go right data final merge X, Y. I'm just writing in left, Y in is equal to right. Okay, again, remember these in options names I give, anything I can give. Okay, in this case, I'm just giving by ID, I'm writing if left. So if I execute this, what would be the output? What output I'll have? So it has to bring in all the columns from the X data set. Perfect. Right, Tony? Yeah, just take a look at it and exactly, correct. You are right, Tony. So the rest of you just take a look at it. Okay, so just guess, okay, what would be the output here? So I'll just give it 30 seconds. Okay, just look at it. All right. So this is what is going to happen here, right? So since you are matching, oh, sorry, I'm supposed to write ID and age here. Sorry, that's my bad. I mentioned only ID here. So my matching variables are, my by variables are joining variables are two here, ID and age. Now what's going to happen since I'm joining it with ID and age here? So it checks by 1, 2, 3, 27. So there's two variables. So it checks 1, 2, 3, 27. Do we have 1, 2, 3, 27 here? Yes, we have. So the first observation would be 1, 2, 3, 27, salary 7,000, location LA, and grade would be A. So when it goes to 1, 2, 4, 28, do we have 1, 2, 4, 28 here? No. So it will be 1, 2, 4, 28, 8,000. Location will be missing and grade will be missing because you do not have 1, 2, 4, 28 on the second data set. are the right data set. So it goes to 12529. Do we have 12529? No. So it will be 12529, 9000, and location will be missing and grade will be missing. And apart from that, so yeah, that's it, right? Because since this is left join, this will be completely ignored because it only takes the values from the left data set. It ignores anything from the right data set. If you see 12429, it's not there. So this will be ignored. So let's just run it.
To do sorting, right?
We have to. In this case, since it is small data set, I'm not sorting. If you see, everything is in order already.
Okay.
But yeah, so it's always better, right? So you should never get, because I've seen hundreds of people committing this mistake. Okay, even in real time, a lot of people I work with, especially the interns, right, who joins the team, so they always forget to write a join because they tend to practice that way when they learn SAS. So that's why it's even if it is a small data set, always write it. Okay. So if you go here, see 1 to 3, 1 to 4, 1 to 5, only 1, 2, 3, 27 is matching. So the records have been written. So now we need to do the same thing in SQL. Okay. PROC SQL, create table, final one, select. So I'm just going to give alias here, a dot star, b dot star from X. Let's write it this way so that it will make more sense. B dot star from X as A. I want to join, left join, Y as B on A dot ID is equal to B dot ID and A dot age is equal to B dot age. Okay, so now let's run it. So this is supposed to have the same output as the previous one, which it will do, right? So the same output we saw in data step. Okay, so this is one example. Okay, so where you have multiple variables and you are performing the join. There would be cases, okay, in real time where you might not want all the columns to be written from the first data set or the second data set. Okay, for example, so you have this. Now you want to perform a left join. Your left join final output should include only ID, age, location, and grade. You don't want salary. You don't want salary, right? So simple. You keep everything as it is here in SAS. Okay, this is a flexibility you have in SAS. Okay, you can. Sorry. The same query you can use it. Finally, you have the drop option, right? In SAS, you have drop option. Okay, but you can go right. Drop is equal to salary. So this option will work here, but the real problem is this option is restricted to only SAS. See, the salary is gone. But this is not suggestible because what happens now when you use this drop option, the entire data gets processed. Okay, at the end, the variable will be dropped. Okay, so in real time, apart from SAS, I mean, if you go to any SQL server or Oracle SQL or Teradata SQL, you will not have the drop option. Okay, so such cases, this is how I have to write it. Even in real time, people, I wouldn't recommend. Okay, I mean, even SAS wouldn't recommend you to write this way because if you are writing here, the entire data gets processed. Okay, so that's why you are expected to write this way as select the variables in the query. Okay, a dot ID, a dot age, comma, because you are selecting only 2 columns from the first table. Because if you put a dot asterisk, everything will be selected. Now b dot, you do not need ID, right? Because ID anyhow is coming from the first table. You do not need. So ID and age both will be coming from the first table. So you do not need them. You need it only them for. So I can write b dot location and b dot grade. Okay. So from X data set. So I'm going to call it alias A. Left join Y data set as B on A dot ID is equal to B dot ID and A dot age is equal to B dot age. So this will work. So it'll not have the salary variable. Okay, so the output is same. Okay, another thing you have to remember, when I selected B data set, if I put B dot asterisk, okay, let's see what's going to happen. If I put B, you can put it, okay, there is no issue. You can put B dot asterisk and say, bring in everything from this one. The problem is you already selected. The select statement definition is basically what columns you want in the output, okay? The select statement definition is anything before, from, and after the select statement is these are the columns you want in your table or the data set. But here when you said a.id, a.age, you are selecting only ID and age because you did not want salary from here. But when it comes to B data set or the second data set, you said asterisk, so it is going to select everything. Okay. Now what's going to happen? Just check it out. Oops. Okay. See, it says variable ID already exists on file work.final1, variable age already exists. Okay. So what does it mean is you are selecting, when you said B dot asterisk, so it goes and says b.id and b.age. But if you see here, the values are already taken from the left table. Okay, A is nothing but your X data set, right? So that's why it is already taken here. So select statement always takes it from the first data set you specify. So since it is already taken, so there is no really need to write b.id and b.age. Okay, so you can just specify the columns that you want from the second table. Okay, in this case, b.location and b.grade. So if you run this now, you would see your output is clean now. Okay. Again, there is nothing wrong in specifying, it just produces warning. But again, if you see here, there is no warning now. Okay. In real time, this is how people tend to write, because you will not always require all the columns from both the tables. Okay. You might have 100 columns in this table, and there would be cases where you just need 4 or 5 columns or 10 columns. So those 10 columns have to be described here. And same case goes to the second data set too. You might not want to write b.asterisk always. So there might be only few columns that you want to return from this table. So you can just specify b dot like this, the columns you want. Okay. In this case, let's say my client comes back and says, okay, you produce this output. Now I have ID, age, location, and grade. Grade really doesn't matter. So I don't want grade in my output. Okay. Can you just remove it? Okay. All you have to do is you have to just go and remove it. Now your output will have only ID, age, and location, because in the select statement, it just looks at select statement and takes whatever that values that are available. Okay, now let's just go run it. Oops. Okay, so this is the frequent error again we commit. Okay, so you have to be careful. Okay, that the query isn't running. Okay, it keeps producing an error. If you see here, syntax error expecting one of the following. Okay, it says that it is expecting, and it will become very difficult for you to understand, right? So if you just go here, so look here, after b.location there is no column, but you just kept comma here. So that's the problem. Yes, Tony, correct, you are right. So this comma shouldn't be this. Whenever you specify a comma, there should be a variable next to it. Okay, but there is no variable, right? But it is directly from state.
Is variable.
Sorry, did somebody say something? All right, see now. So this is how it works. Okay, now let's make it even more complicated, right? So yeah, this is where you would understand why SQL is so used in real time. Okay, let's just remove this. Okay. So even age we don't need. Age here. So I have another data set here, Z data set. So the Z data set has location and let's say rank. So I have this output now. Now in data step, okay, so this is where the biggest difference comes between data step and SAS, SQL, okay. So I have these 3 data sets. The common variable is ID and age here. So I just want ID, age, and location in one data set. So if I join by ID or if I merge by ID, age, and location will be in one data set. So I have a third data set which has a location which is relation with this one. Okay, my final output should have this. Okay, I want ID, age, location, and rank. So my final output should have these 4 columns. Now I have 2 tables, okay, or 2 data sets. In data step, do you think it is possible to merge all these data sets in a single step? Can we merge all these data sets in a single step, single data step? No, we cannot, right? Because in data step, if you want to perform a single merge, so across data set, there should be one common variable. Okay, in this case, if you see here, these 2 data sets, you have ID and ID. In the third data set, you have location. Okay, so ideally, what's supposed to happen? First, you merge these 2 data sets, then you merge it with this one. So it has to be 2 different steps. Okay, so this is what I'm going to do. So first, sort all the data sets. Proc sort data is equal to X by ID. Proc sort data is equal to Y by ID. Run. Okay, now data final. First merge X and Y data sets by ID. Okay, now it worked. The problem now is, now I want location 2, right? But I don't have location here. Sorry, I want rank 2. Rank is in the third data set, but it doesn't have ID. So now what I have to do, I have to sort this data set, the final data set, by location, and the Z data set, the third data set, by location, and merge these 2 data sets. Okay, see how it is getting complicated. So you have to do it in 2 different steps. Okay, so basically first you merge X and Y data set, then it will have location, then merge it with the data set that you want at the end. Okay, so now you merge it with by location. So this will have your final output. Okay, what you expected, you wanted ID, age, location, rank in one data set. Now if you see, ID, age, location, rank is in one data set now. Again, so 1, 2, 3, 27, sorry, one value must be missing here. So 1 to 5 is missing because 1 to 5 is not available in the starting from the second data set. So that is fine. But look at the complexity here. You had to do it in 2 different steps here. Okay, and you are sorting the data total 2 here and 2 here, total 4 times. Whereas in PROC SQL, okay, it's a lot easier. Okay, you do not have to perform in multiple steps. So you can go here. So this is very, very important thing. In real time, this would be the cases. Select. So first I'm gonna write a dot star, or if you want to select the variables, you can select it. Okay, b dot star. I'm going to write c dot star, which means the third data set, which is my this data set. Okay, z data set. Okay, so now I'm going to write first, select the first data set from X, which is a data set. I'm going to write left join or full join, whatever you write, right? So let's pick up only left join here. Left join Y as B on A dot ID is equal to B dot ID. Okay, so if I run this one, so until here you have the A and B data sets, X and Y data sets joined. Okay, which means these 2 data sets gets joined here until that step. So by this time it gets to it, so SAS will already have ID, age, ID, location. So next, on top of it, you write another output, left join Z data set on B dot location is equal to C dot location. So when I say B dot location, the location variable is in the second data set. So when I say B here, so B is nothing but your Y data set, right? So G as C here. See, first you are joining A and B data sets, in your case X and Y data sets. So by this time SAS executes this statement, it will already have location inside it. So that location is coming from the B data set. On top of it, you are writing left join and joining it with a Z data set. On top of it, you are writing B dot location is equal to C dot location. Okay, so this output, So it will produce warnings. Okay, you can ignore them. Again, it is created. Okay, let's just go XYZ. Just look at it. So this will have the same output as what we produced in dataset. Okay, so this output is from dataset and this output is from SQL. So if you look at it, both outputs are same, but which one is efficient? This one is efficient, right? So you did not have to go to multiple steps, sort the data, and again combine it. So everything is done in one simple step here. So likewise, you can join multiple tables with a different by columns. Okay, different columns here. So yeah, these kind of cases are very, very useful in SQL. Okay, where you want to join multiple tables and you could do it. And there would be cases in real time where you want to join multiple columns also. In this case, we have only ID. There might be ID age you want to join by. You can join them. Okay, so that's how you perform multiple tables with different by column values. Okay, now let's give another real-time scenario. Okay, this is a real-time scenario again. You have, let's say, customer ID. Again, for our understanding, customer ID, account. Again, I'll give you some, because this is a real-time scenario. Okay, I mean, not the data, but the scenarios are real-time. So we have this data. Now, what ID I have? Account activation date. Let me write account activation date. Okay, so I'll give you a context of this so that it will make more sense. Okay, so okay, so we have this. Now, my objective here is I want customer account, a customer ID, a customer account balance, and customer account date in one thing. Okay, so for this customer, my final output should have customer ID, account balance. So if you look here, you have multiple. So the same customer ID, you have multiple. Okay, so which means on a different dates basically. So this is fine. Okay, this is not a duplicate. The data is this way. Now what I want is I want customer ID. For each customer ID, the account activation date has to reflect. Okay, so this will work fine. Okay, so if I go join it, so let's go step by step here to make more sense. Create table, final. X starts. I'm not taking aliases this time. I'm just writing X. Let's join it with Y dataset on X start ID. X start cust ID is equal to Y dot cust ID. Okay, so let's just run it. So this is, oops. So this one too, right? Format, ACT date, DDMMYY10 dot ACD date DDMMYY10 dot. Okay, so oops, there must be some error. Oh, see, I missed. I think somebody guessed it. Yeah, so I forgot to give. This happens all the time, okay? Because we are writing queries, we always miss something. Still, it produced an error. Anybody can guess?
Custody, one is a character, another is numeric.
Yep. Good catch. Good catch. Yep. Okay, now it worked. So if you go here, your final data set. So it is fine, right? So for all the 1 to 3x, this is the one, and for all 1 to 4 ABC, this is the date, and so the dates are fine. Now, this is a proper join, okay? So you have no issues if the requirement stops here. Now, somebody comes to you and say that, okay, what do we need is, we want the customer ID total account balance. I want this way. I want customer ID total account balance, and you want account date. So I want customer ID, total balance, and account date. Okay. So so if you see here, for 1, 2, 3 XYZ, the total balance is 80,000, 150,000, and 177,000. Okay. So my final output should look like 1, 2, 3 customer ID. The final output should be customer ID 1 to total balance. Okay, and the account date. So the customer ID should be 1, 2, 3 XYZ. So whatever, right? The dates we have 13/05/2019, 1, 2, 4 ABC. Whatever the money, the balance, okay, randomly 14/6/2021, 1, 2, 5 ABC. I'm just gonna take a random number again, 17/05/2021. So this is 14/60/20. So this is how the output should look like. Okay, so the total balance and the account date. All right. So how do you think we do it? Okay. Right, Srinivas. So so there are two ways to do it. Okay. So first thing, first let's go by the straight approach. Okay, so that everybody would understand it. So this is the output that I got. This is the output that I got. Now on this output, I can write another query and perform it. Okay. So this is how I can go. So I join them, then I go to a different step. Let's say PROC SQL create table, final sum as select. You do not have to because it is just one table, right? So select, first you select the customer ID from it, then you write sum of, again we talked about the grouping, right? Grouping some account balance as total balance. So first I'm finding out the balance. Okay, let's select the account activation date and let's go. And this is a very, very important concept. Okay, creating summarized tables is a very, very important concept. Okay, now I do not want sum of account balance, and I do not want account balance column. Okay, I'm not using it here. I'm not using it in the select statement. Okay, I'm using only sum function to select the values. So the final output will have only customer ID, account date, and sum of this. So from which table? So from the table called final, which we created before. Okay, now let's just run it. Okay, so I'm not doing anything. So like I said, we just go one by one. Okay, so final sum, let's look at it. So it worked here. If you see here, the sum is assigned to the entire thing here, 602000. So what happened here? When I said sum of account balance as total balance, the sum has been assigned to each one. So it's a total sum. You did not tell you want sum by customer ID, right? So that's why the sum has been happened to the entire thing. So you have to add a group by a customer ID, group by customer ID. So remember group by, since you want sum of account balance by customer ID, so I have to add group by. So now let's run it. See now, it worked. It worked here. But again, you still, again, let's go back to the output. My output should supposed to look like this. Now what happened? You still have multiple records, right? You have the entire data. I do not want this. Now, what you have to do is you have to add account activation date to date 2, right? Because you want to group it by 2. Account activation date, group by account activation date. Now go here, it groups it by those 2 columns. See, this is the output we have. So this is the output we expected, right? So whenever you want to sum it by, so make sure you use group by for those columns. Okay, it can be 1 column, it can be 2 columns, or it can be multiple columns. Okay, don't worry, I'll give you some scenarios to practice work on, because this is the most common a task or requirement that you frequently get. Okay, especially for summarizing tables. Okay, this is fine, because but there is a problem with it. Okay, you had to write it in 2 different steps. Okay, so instead of that, you can use this join itself. Instead of writing 2 different queries, you can use joining itself. Okay, so let's just go and see how do we do it in single step. How can we do this in single step? So first one, so this is how we do it in single step. Okay, so PROC SQL create table. I'm just going to create new select. So from the X table, I'm just going to select only the customer ID, and sum of X dot account balance, or you can select Y dot Y table account activation date. Okay, I want only, because you do not have to put asterisk, because even if you put asterisk, that's fine. But let's just write Y dot account date, because select statement will define what columns you want. Okay, now you write sum of X dot account underscore balance as total balance. Okay, let me just break it into different pieces. Okay, so now you go right from X data set. I'm just you can directly join it, left join, or any join you want. Okay, left join Y data set, on X dot cust ID is equal to Y dot customer ID. So again, first let's run it. If you run this one, it's going to work. Okay, it just joins everything and produces the sum again, similar to what we have seen before. It is going to produce the sum for the entire thing. Okay, but this is not I wanted by the customer ID and account date. So you can use group by here too. So you do not have to go right group by. So Vani did not join today. All right. Okay. So since you are adding, right? So you can just add this group by columns. Okay, so it will work. Go to the log. Oh, sorry. See, again, I wrote A dot and B dot. Okay, this is what happens if you are used to that kind of programming. So X dot, comma, Y dot. Okay, now see, this output is same. So the output that we produced using 2 queries here could be produced with 1 step itself. Okay, all you have to do is So in order to do this, first you need to know these 2 steps to perform. Okay, so if you know that, this will be a lot easier. Okay, so this is the reason SQL is so efficient. Okay, we cannot do this the entire thing. We cannot do this entire thing in data step. Okay, so in data step, you want to perform, first you need to merge them, then go to a different step, again sort it, or use any of the procedures like proc report or proc means, and then perform it. Here, see, everything is done in one particular step. Okay, I join them, I summarize the table at the same time. Okay, another thing you have to remember, this is very, very important again. Here, so I grouped it by some value, right? Grouped by customer ID and activation date. So in this case, we have 2 columns, that's fine. Just imagine you have 10 columns to group by, right? So you do not have to always write them, okay? So you can just specify their positions, okay? If you see here, customer ID is in the first position, you can just specify 1, 2. So which means you want to group it by the first column and the second column. So it looks at the select statement and goes, okay, the first column is customer ID. So it will just group it by customer ID. The second column is in select statement is activation date. So it will just use those columns. So run it. See, it will have the same output. Okay, so remember this too. You do not always have to specify the column names. You can specify their position in the select statement also. Okay, cool. Okay, so this is how this works. Okay, again, I'll give you a couple of scenarios to work on, but remember this is one of the highly used concepts. Okay, especially when you have to choose between data step and SQL. This method is followed by any experienced programmer or any experienced developer. Right now. So we talked about left join, right? We talked about joining multiple tables. We talked about joining and performing summary and everything. Now, let's talk about right join. Okay, so you have to be careful. Right join is very rarely used join in real time. So mostly people would prefer left join is the mostly used one. Okay, so again, if you look at any business context, you'll always get requirements where the left join is performed when you have that main table and you are trying to get information from the second table. Okay, so always the business logics will be built around that. So mostly used one is left join and inner join and outer join. Okay, right join is not preferred too many, but again, since that is a concept, okay, there will be requirements too where you can perform right join. So let's see. So right join is again, you want to join this table. So left join brings in all the values from this, right? Whereas in right join is pretty opposite. Okay, so it brings in all the values from the right table and matches it with the second table. Okay, for example here. But you have to be very careful while understanding it. Okay, in SAS, not in SAS. Okay, it's a little tricky situation here. So I'm just going to write again in data step. How do we do it? Data final merge x is equal to left. I'm writing in is equal to left, y in is equal to right. I. So if you write if right, so this will become your right join. Okay, so basically it looks at this 1 2 3 and 1 2 4, and it brings in only those values. Okay, so if I go here to the final data set, so it'll have only 1 2 3 and 1 2 4 because you are saying right, so it will pick up only the values from this. So if you see 1 to 5 is ignored because it is not there in the right data set. Okay, so this is how it works, and we all remember this from data step merging. So we can do the same thing in SQL, but PROC SQL create table. I'm just going to write final one select x dot star. You can use asterisk y dot asterisk from x right join y on x dot id is equal to b dot y dot id. So let's just look at it. So this will be fine. Okay, this query will be fine. So this is fine. Okay, this output and this output would be fine. Okay, now just imagine you have a 1 to 7. You have a 1 to 7. Okay, this is where the problem begins. You have 1 to 7 ny. It is not there on the X data set, right? So just see what's going to happen. See now? So you see something odd, okay? You see ID and age values are missing, okay? The reason being you said right join, so it takes values from only this, okay? ID and location. But the select statement, you specified X data set first. So the select statement first goes and select ID and age from this data set. So this 1 to 7 is not there. So it matches only 1 to 3 and 1 to 4. This 1 to 7 is not there on the first data set. So the select statement will bring in only the ID and ages from IDs from this table, not this table. So if you interchange it, you put y dot, because you are saying the left join, right join on y data set. So you have to put this data set first in order to bring in the values from this. Now run it. See now it must have worked. So this is the only confusing part. If you, of course, if you remember how does this select statement is working, it will be a lot easier. So remember, select statement, based on order what you select, it will select it. Okay. So whenever you specify right join, you have to flip it. Okay. Make sure you specify in the select statement y columns first, so that everything will be written from the y data set or the right data set. If you, as usual, you specify the left data set here, the first data set you specify, it will return only the values from this data set.
Gangadhar? I think that's not the case, right? Even though you select what are the columns, it should be depend upon the join what you're giving, right? Why we need to flip that one? Because you are selecting all the columns there. Just select only the columns from Y data set.
Select the columns. Yeah, but you are selecting the columns, but look at the values.
No. I'm saying even whatever select statement is there, that's fine. Whatever your right table, it should pick from your right table. That's the only basic functionality of the right join, right?
No.
I don't think so. I still contradict this one, because you will never flip your data sets.
Okay, can you write and show me? I'm very curious to learn it.
No. What I'm saying here, you are saying to flip your data sets, right? X to Y and Y to X, and then you give your right join.
Correct. No, if you look at, I did not flip the condition. I flipped the select statement.
Correct. So because see, you are selecting from two data sets, correct? Your from is what? X, correct? So that is what depends from which table you are selecting. That matters there.
No.
Right. Yeah. From which statement? So because your X and Y is your right table, right?
Correct.
Yeah. So basically, your select will be because you are selecting all the columns there. You can select what are the required columns from whatever the table. That's fine. But the right joins should pick the data from the Y data set only.
No, that's not how it works.
I don't think so. You can still go and look for that query, but yeah, that's the right. Whatever right join you're saying, right join is on works only on Y, but not on X.
So you have written X dot star and Y dot star.
No, that's your columns, Gangadhar. You're selecting the columns. I'm not talking about the columns. Leave about the columns. Just leave about the select statement completely. Your right join is working on Y data set or not. That's the only thing I'm looking at.
Okay, I mean, that's what the definition itself, right? It is working. And what's your question here?
But the flip for right join, we need to flip the columns. It's not the case, right? That's what I'm contradicting there.
Okay.
No need to flip because you're selecting all the columns. So it will bring all the columns from both the data sets, but the join is happening on the only Y data set.
Okay, so let me run this. Okay, so you have this query perfect. Do you see any issues with this query?
No.
Okay. I ran it. How do you explain these missing values?
That's what I'm saying. It's a selection of your columns. I'm not talking about the columns. I'm telling the right join happens on your right table only, period. It doesn't even look for anything else. Your selection can be any. If you have 10 tables, that's fine. But so, I'm saying here, the selection might be different case. That's okay.
Let's go back. When I started,
so your criteria is to pick. Your criteria is to pick the data, the columns from the Y. That's fine. You can directly select those columns.
No, of star. Again, you are getting it entirely wrong. We are not talking about the columns here. We're talking about the values here. So what is the point in performing right join here? So what is the definition of right join?
Okay, let me tell you. Okay, let me explain the definition for you. Okay, so right join or any join, right? So when you're giving a right join, it select all the columns from your right table. And if there is a match from your left table, it will pick those, or else it will throw all the null values for those. Is it my statement right?
Correct.
Okay. So though you're okay, what columns you have in your right table here?
Columns we have ID and location.
Okay. So what columns you have in your left table?
ID and age.
Okay. So you are selecting ID, age, and location, correct?
Correct.
So that's the point I'm talking about. When you doesn't have a column which is part of your Y data set, it will always throw null for those things.
Correct. But okay, let me put it this way.
Okay, that's fine, Ganga. This is a small thing. Okay, I got what you're saying, but I don't want to waste time on this one. But I still
no. Let's. I mean, if everybody has this question, right? So the point of right join is right. It brings just opposite of left join. It brings in all the values from the right data set. But the problem is when you run right join, you see, forget about the variables. Okay, variables everybody understands. Okay, you want basically trying to get age from here. But when it says, the definition itself says that it has to return all the rows from the right data set. Here, if you look at it, 1 to 7 is not being thrown. 1 to 7 is not reflecting, right? Why? Because it is there in the right data set. The Y data set is your right data set. It is there, but in the output, it is not being displayed. Why? You see what I'm saying? It is not displayed here because your select statement first selects the value, because you defined it here x dot asterisk. It takes this ID from the first data set itself. So that's when I said, if you want the right data set values to be displayed, you have to flip this. So you have to select first from the Y data set so that your 1 to 7 will be reflected. Or if you still, I mean, we can always catch up if you feel that it needs more elaborated explanation. All right. Okay, it's okay. We'll move on. Now, so that's the right join. Okay, so you always make sure, again, the situation scenario goes same way. If you have more than one column, or more than, if you want to summarize it, or if you want to make sure you have multiple columns or different data types, the rest of the concepts remain same. Okay, so the only right join is the right join does this. It selects, you are basically performing from here to here. Okay, from the second data set to the first data set you are trying to match. All right, now a little more complex example. Okay, so anyhow, I'll just ping this to you guys, can work on it, because if I explain, everything might look good here.
Hey, Gangadhar. So my question is a little different. So as long as you know left join, right? Can we switch the table?
Yes, we can.
Y and X, and it's going to be the same, right?
Yes, you can.
So basically, if you know one join, then that's fine then. Left or right?
Yes. Yes.
Okay.
You can always switch it. Yeah. Let's give name. Okay, so this is one output. Okay, now what I want is my final output should look like name. My final output should like name. Again, I'm just making it a little complicated. Sorry, did I say grade here? Let me make it gender so that it will make more sense. Gender, name, gender, location.
Hey, Gangadhar. Okay, can you send the recordings after the session is done? So I'll be dropping now. Okay.
Okay, sure.
Okay, thank you.
Okay. So who dropped? Srinivas, right? Srinmugam.
Srini.
Srini, okay. I always get confused with both of your voices. I'm sorry.
That's fine.
So, my final output should be like this. Okay, I'm just giving you some real-time scenarios to work on so that again you can figure this out. If not, oops, Mark. Let me change it to Mark here. John. Oops. John 20. Location CA, grade 2. And John J. Location should be missing and rank should be missing. John again. Male, location and rank should be missing. Okay, so this is the output I expect. Okay, so again you have to use join, but there is something else you have to do. Okay, so instead of male and female, I want M and F. I want male and female conditions to be. Basically, if it is so. Okay. So you can easily figure it out. Okay, I just want to give you, because in real time when we join more than 2 tables, we can always write case when statements and perform it. Now, another case scenario. Age. I have 3XYZ 28 7,000. So 31 90,000 run B. Import employee ID, age. Employee ID is supposed to be character, location. Let's say I'm going to call it height. Location would be LA. The height would be 124 ABC. Oops, by okay. 29. 8. 0.20. Okay, so let's put, so now the final output should be I need employee ID, so ID, not employee ID, and age, location, and the final should be final salary. Final salary, this should be 123 XYZ 28, and location would be LA, and the 10% of it. Okay, final salary should be 70,077 plus this one. Okay, I'll explain you what I meant by that. CA 8,000, right? 8,800. So this is the output. Okay, so basically I just want to join it by ID and age. I want to join these tables by ID and age. I want employees location, and I want to basically so these are the salary percentages. Okay, so this is the current salary, and their manager decided to give 0.10% of hike to this employee, and 0.2 20% to this employee. Okay, so your final output should be extract 10% from it and add the 10 plus this salary, so it will be 77,000. And for this employee, 8,000, 10, 20%, again, 9,600, right? Okay, so this is how it's supposed to look like. Okay, so again, you are going to join, and output I want is this one only. I just want this one. Okay, so you have to figure out, so what logic has to be used to do it. All right, so this both should do it. This both should help you. I mean, to get complete hold of, because this is how it is going to be. Okay, in real time, you join them, and there'll always be some business context or operation that you basically have to perform on top of it. Okay, so yeah, if you do this, basically you'll get it right in majority of the scenarios. Okay, let me bring it to you. What happened? Okay, so I think, yeah, we are past our time, so we'll catch up tomorrow then. Okay, thank you so much.
Hey Gangadhar. So when you send the SAS file, you sent for August 24th, right?
Yeah, yesterday's I'm still sending it. Okay, see, some issue happened, I couldn't send them. Yeah, now I just mapped them.
No, even we don't have for 23rd.
23rd also?
Yeah, 23rd and 28th.
23rd?
Yeah. Oh, that's June. Yeah. Just the 23rd one.
23rd August?
Yeah. 24th you sent it, but not 23rd.
I think I put them in one email, I guess. Let me check.
Oh, maybe it's in the 24, 23 and 24 is in the same file?
Same email, yeah, here. 23 and 24, I just sent it here.
Oh.
Here, let me, oops, this 3, right? I missed one, and yesterday I shared it. Basically, this will be that.
Maybe that's the one you sent the June 28th? No, that's a video, right? Okay, SAS file.
SAS, 23rd August. No. For SQL, I'm maintaining only one file.
Okay,
I'm not creating individual because no, I do not want to confuse you, because here pretty much everything will be in one, right? Because we are comparing it. I do not want to break it, so I'm just putting everything in one place.
Okay, so you're going to send this one today?
Yes.
Okay, that's fine. Thanks.
Yeah, Tony. I'll put it. Okay, I'll put all the classes in one Google Drive and share the link with you. Yeah. The problem is, I was thinking, okay, I'll put it in anyway. Another thing I forgot. What did I forget? Yeah, so if you guys can hold on, I wanted to give you one base SAS certification questions for you. Again, if anybody interested in writing certification, right? Again, you do not have to sit for 2 hours and write it. So I filtered out the important questions, which will be repeated again and again. Again, maybe you can write them now, because most of the concepts every base SAS concept is already covered. Yeah, so these questions, okay. Again, there will be 120 questions, so I filtered it for your convenience. So some of the questions, there are about 120 questions in this, but again, this is not from one paper, okay. 144 questions. So I switched a few questions to make sure you guys are comfortable with it, okay. And again, you do not have to write them immediately. So there are some questions where the answers are already there. I do not want the answers to be given to you. So this I give out to everybody. Okay. This certification will be a little different from what you see, and sometimes it will be very frustrating to read these questions because they confuse you a lot. Okay, these questions intentionally will confuse you a lot, just like any other multiple choice questions, right? Everything looks same. At the same time, it will take a lot of time to read them too. Okay, so but don't worry, I'll give you ample of time, or else I'll just again short it again. I'll just send out 20 questions each, so that it will be easy for you to do. Okay, so that's next thing. Oh, you are Nitya. So I think I have dumps here. Okay, let me share it to you. You are talking about base SAS certification, right? Yeah, I got the certification dumps. I'll give it to you. Yeah, this is the certification dump. Not the dump, basically it's a guide. So this will help you. Okay, this will I'll share you, and I should have the dumps too somewhere.
It says 2007, right? Is there is a new one, or it's fine?
It's the same one. The main, yeah, the core, I mean, the functions and everything, right? So whenever they add new ones, they won't change it. So this certification dump, yeah, it should be good. The core concepts haven't changed.
Okay.
Maybe starting next year, once everybody is onboarded to SAS Via, they might change it. Because SAS Via has some additional functionalities, especially in the libname statements and stuff. Yeah, this one is good too. I'll share it, and I should have a few more dumps somewhere. I'll share it. Let me download this. I should have another one. This one is useless. Yeah, I'll check it out. I mean, it gotta be in somewhere. Yeah, I'll share it with you guys. Okay. So I'll share these questions with you today in the email separately. You can just go through them. Right. Thank you so much. I'll see you tomorrow.
Thank you.
All right. So, okay, let's do the first one. Okay. Here you remember the requirement, right? So I just want to join this. My final output should be name, gender, location, and rank. But the gender value is supposed to have wherever M is there, it's supposed to be male, and wherever F is there, it's supposed to be female. Okay. So let's just write this down. So PROC SQL create table new select Z. Okay, so I'm gonna select the variables Z dot is, and so here the gender part, right? So you can go right case when Z dot gender is equal to M, then define it. Okay, male. When Z dot, because it is coming from the Z table. Okay, so Tony might be wondering what is Z. So in India we call it Z. So basically it is, we call Z Z. Tony, so
I noticed.
Yeah. So
we no need Z dot age, right? Because
yeah,
it's not in.
What did I say? Yeah, we don't need it. Yeah, we can just eliminate it. So this we'll select name and gender. So this is fine. Then you want everything from the second table, right? Location, name, and rank. So you're gonna put asterisk K. Okay, so from Z, you want to perform inner join, I guess. Inner join or left join? What did I say? Okay, so it's a full join or left join, because left join A on C dot name is equal to A dot name. Okay, so this is supposed to do it. Oops. Oh, sorry, I forgot to end it. So when we update it, so just write end as gender. So we have to always end it, and I forgot a comma here. Four rows and 4 columns. Okay. Oh, see, it worked. So it has converted. Okay. So I mean the rest of the values doesn't matter. Okay. So this was our requirement, right?
Even in the you said female CA2 for John.
Maybe the value is not okay. Only for John it went. That's what you meant, right?
Yeah. So John, you have 2, right? So 28F and 28 male.
Oh, sorry.
So it's automatically joining there for 2 Johns. That's what I couldn't get it.
Oh, yeah, okay. Oh, sorry. Yeah, I didn't notice this. Okay, let's just, yeah, let's say John's now. Okay, now ours will change to John's. Now it should make sense. Yeah, so since we have twice, right? Now it must have worked. New, if you go, oops. Yeah, John's female YCA is not coming. Oh, again, this uppercase.
Yeah, right.
Now it should be working. Okay, so yeah, so that was my bad. Okay, so this makes sense, right? So
yeah,
while planning itself, yeah, so the case when statement, you can refer it to the table and you can add conditions, and these kind of cases are very frequent in real time. Okay, where you are joining 2 tables and you might require to write some conditional processing and do it. All right. So the second one, what did we say?
There will be a sum of the calculations.
Yeah. So the sum of calculations. Okay.
Even multiplication and addition. Yeah.
Yeah. PROC SQL, create table, new one as select. So I'm gonna select everything, or I can final salary. I want ID, age, location, and final salary. So A.ID, A.age, and B.location. I want location from the second table, so I'm just going to select location from the second table from. At the same time, I want B.salary into C.hike. Sorry. A.salary into B.hike. So this is what you did.
You can open it. I did little different calculation.
Yeah.
Salary, and then I put plus and then added again salary.
Okay. A.employee ID is equal to B. Employee ID, right? Employee ID is equal to B. Column employee ID could not be found. Okay, so I just mentioned ID here, so it has to.
That's my code.
Okay. It just has to be ID. Then now run it. So 2 rows and 4 columns. Where is new? Okay. So and yeah, I forgot to give it a variable name. as final salary. Okay, so this is what we expect. Oh,
no, actually you had to plus the total salary again.
correct. So pay dot salary makes sense, right? So you just have to do it again. Now it must have worked. Makes sense now?
Yeah, that's right. Can you check my code? I sent in now.
Perfect. Yeah. So yeah, this is right. It'll work. So some works too here because you are just adding one, right? Oops.
Gangana, when we do this method where you're adding instead of using sum, what happens when you have missing values?
When you have missing values?
Yes.
This will, right? It will produce a missing value. The final value would be the missing value. So the operator right here, it will produce a missing value. Yeah, that's a good catch. Yeah, that's a very, very good catch. So let's see what's going to happen. Okay, so this is a plus operator, right? Let's see. Yeah, so then what Shanmugam did is right, because okay, so let's just see. Okay, let's forget about it. Okay, so let's assume you understand what I mean. I'm just remove the hike here. I produced hike as a missing value, and you have A and B, right? So A has salaries and the B has the hike missing. Now, when you go here and run this one, see, this would be missing. Okay, I mean, because this hike is missing and you're trying to add hike plus this one, so you get what I'm saying, right? Remember, we talked the same thing in the data step 2. So this plus operator, whenever you use it, this is known as sum operator. Whenever you use it, if one value is missing, in this case the hike is missing and you are trying to add it to salary, so it is not going to work. The final output would be missing. Okay, okay, even in this case, right? Okay, yeah, that doesn't matter because okay, even here also it will produce it because yeah, we got it right. New one. Oops, what did I do there?
Close the bracket after hike.
Yeah, that's what it is. So now it will be the missing value only because 71,600. Don't they have? This is salary for 1 to 3 XYZ. How much we have? 70,000. So it is missing. What happened? Was correct because I'm trying to perform in a join. Oh yeah, so the problem here is we cannot use sum operator. You know what happened here? When you use sum operator, it is summing up the entire thing with this. Okay, so what does it mean is 70,000 plus what is that 20% in 20% 8,000, 1,600, right? 1,600, isn't it? So if you go look at it, it has sum that 71,600. So the second one will be fine, 8,000 plus this one, but the problem arises with this one, 70,000. It is summing the entire thing, 70,000 plus 20% of it. So probably what we have to do is we have to put another case when statement. Yeah, that's a good question. Yeah, the missing value produces missing value. So your requirement is okay. Okay, let me reiterate the requirement here. It's a very, very good example to talk. Okay, where is AMD? Okay, so now this is fine, right? So let's assume you have all these employees with salaries, and now these employees have received the hike. So if he hasn't received hike, it will be a missing value. Now the requirement should be when there is a missing value, it should remain same. That the final salaries should be same. Okay, in this case, for 1, 2, 3 XYZ 28 LA. So 1, 2, 3 XYZ, the hike is missing here. So whenever the hike is missing, it should be the same salary. So it has to be the same salary. It should not do any mathematical computation here. So since it is missing. But for those non-missing values, again, this has to be computed based on this salary. This has to be computed. Makes sense, right? Because when I use plus operator, even in your case, weird, what happened? B dot AD, B dot location, sum of A dot salary into B dot high. Oh, let me go here. Maybe. Oh, sorry. I don't remember. Okay, let me just put it there. Just want to compare. What did I write? A dot salary. B dot hike. Yeah, so here, right, even if you look at the final one, what did I do here? Yeah. So yeah, you added group by. That's the, now it makes it more complicated, isn't it? I should have given this way. Okay, now it makes more sense. If you have order by AD, group by, now it will be missing as expected. Because okay. So you see what is happening here? He added group by. Okay, so let's just put it one by one. Okay, so okay, again, the reason. So if you don't have missing values, it will work fine. Okay, if you don't have missing values here, both will work fine. Okay, A and B. So if you go here, so this is your query, right? So it will work fine. And the one that I wrote, this will also work fine. Even if I just put this way, it will work fine. So new one, where is it? So this will also work fine without any issues. The problem arises when there is a missing value, which is very interesting here, because again, the fundamentals, right? If I multiply any value with any non-missing value with a missing value, so what's going to happen? Okay, for example, my value, can I write 10 into dot So what's going to happen here if I write it this way? The final value will be missing, right? The final value will be missing. So if I go to Z, this will be missing. Okay, this is exactly is happening here. Okay, you are trying to multiply the salary with a missing value. So that's when the problem arises. That's when the problem arises. Okay. The question you asked, right, Tony? So this is what this is. Okay. If I have total is equal to sum of 10 plus 2 plus, let's say I have a missing value. The third one is a missing value. So now what is going to happen if I run this? Sorry, 10 comma 2 comma missing value. So I'm going to write final 10 plus 2 plus dot Z. See, so the total one produced the value. This did not, okay, because it has a missing value because you are calculating plus here. So, but here the case itself is you are trying to multiply it. So if this value is missing, so you cannot multiply it, right? If there are no missing value, that is fine. Everybody agrees. If there are no missing value, the logic that we have here, this one will work fine. So even in the sum case here, the one he has written, when there is a missing value, the problem arises because when I'm trying to multiply the salary by hike, this hike is missing. So ultimately here you'll have a missing value. It doesn't matter even if you have a value here. So such cases, what are we supposed to do? You have to put a case one statement. So you have to go right case when B.
So for this, even though if you multiply, it's going to be 0, right? But you are adding plus salary. So that salary should show up, right?
No. Here, okay, first, which statement do you think? That's a good question, right? So first, which statement do you think gets executed here?
Multiplication.
So multiplication, right? Yeah. So when this gets executed for this particular observation, right? So let's say this is what is going to happen. Okay. So let's just say this will just replace 70,000 into missing. So now what will be the output here when this runs?
0.
No, 70,000 into a missing value. So just like what we see here.
Yeah, it's nothing, right?
Yeah, the null value will come out, right? So when the null value comes out, so you are literally saying that dot missing value plus a dot salary. So it will still be missing, right?
Okay.
Yeah. So
even addition with null doesn't work.
Null doesn't work. Yes. Because this is the one that gets executed first. On top of it, remember, on top of it, this sum function will work. So here, the calculation itself produces a missing value. So anything you do on missing value will be missing value only here. Even though the sum function ideally has to work, but your missing value itself is the calculation itself will produce a missing value. It will be nothing but sum of missing value plus a dot salary. So anything then missing value plus a dot salary is missing because you cannot perform a mathematical, you cannot multiply or add anything with a missing value. So that's why it produces 0. A missing value.
0, okay.
Yeah. Missing value. So okay. Yeah, so such cases, what you have to do is, so you have to go right case when B dot hike equal to missing, then you have to say that you want A dot salary as total balance. So whenever there is a hike is equal to missing, what you just want to do is you just want to add this salary as a total balance. So you just want to replace instead of producing missing value. So else your condition would be this: sum of and as total balance. Okay. Now, if you run it, oops, must have, yeah. Where is it? Did I not put in? Oh, sorry. Okay, so now it must have worked. If you go here, when there is a missing value in the hike, it must have produced, it must have replaced it with original salary. When it is non-missing value, it must have performed that the calculation. See, 70,000 and 9,600. It makes sense. I know it's complicated because
yeah, that's right.
Yeah. So yeah, Shanmugam, yeah, the query that you wrote for if there are no missing value, it will perfectly work fine. Okay. Even I didn't think that too. Thanks for bringing this up. Yeah, it's something again we have to remember. Okay. So if you have a missing value and you're trying to perform a mathematical calculation or any arithmetic operation on it, the value will be missing only because in SQL, whenever you write a function, first the inner object, not in SQL, right? You have to look at this execution. Okay. So this sum function doesn't work first. This will work first. So the moment it executed, the output would be missing. So sum of missing would be missing only. So then it doesn't matter what you have here because it is anyhow is a missing value here. Right?
Okay.
Yeah. Yeah. So yeah, I mean, good thinking, right? Good thinking. You have to think that way. Okay. So whenever you have queries, okay, think that way. So it will be a lot easier to learn it. Okay. Now, so I told you we have to go to subqueries, but before that, I need to talk about a few more statements. Update, alter table, insert into. Okay, so again, we'll compare what do we have in SAS for this, and then we talk about it. What do we have SAS? What do we have in SAS for this particular methodologies, and then we talk about it. All right. So let's assume I have a table called X. Okay, so this X table, I have to talk about this too. Delete. This also we need to talk. Okay, these are delete and drop. Delete and drop. Okay, these statements let's talk in SQL. Okay, and let's see the equivalent in SAS. Okay, so now you tell me. So let's assume I have a data set called X here. This X data set has age values. Okay, age 14. Now what I want to do is I just after some time I realized that I want age values to be multiplied by 2. Each age value has to be multiplied by 2. But I do not want to recreate this data set. Okay, so I just have the X data set here. Somebody created some time ago. Let's say it is in a permanent library, not in work library. And somebody asked you to update the table, just add +2 for this age variable. Okay, so without recreating the table. Okay, so what do we have in SAS? What do we have in SAS?
Sorry, I couldn't hear. What is that?
So I have a table called X here, a data set called X. And now I just want to update age variable value here with 2. I just want to add 2 to each and every age value. So what should I do?
I mean, age is age into 2, right? New
Yeah.
age like we did before, yeah.
No, so if I write this way, again, you are recreating the data set. I do not want to recreate the data set.
Oh, okay.
I do not want to recreate. I just want to update it. So we talked about a concept. Because just imagine you have 100 million records in this data set. Recreating just to update one column values, you are recreating the entire data set. It might take 1-2 hours to run the entire thing again. I just want to update only this particular column. Somebody pinged something. PROC data sets update No, not update. So yeah, so do you remember modify we talked about?
Yes.
So this modify statement, when you run it, this will update it. Okay, so if you see here, if you go, now it must have updated it. But if you look at the log, it must have already told you. See, it has updated. It did not create it. It updated the table. It updated the data set. It did not recreate the data set. Okay, so it just updated it. So this is the this is what we have in SAS. Okay, data step basically, without, if you just want to update it. Whereas in SQL, okay, we have PROC SQL. So we have a table called statement called update. So you have to specify the table name, and then you have to specify a statement called set age. Then you would write the condition you want. So now what's going to happen? Run it. See, 19 rows were updated. So it again must have updated with another 2. See, it updated again. So again, don't get confused. Here in SAS, we use modify. Here we use update. Okay. So set statement basically defines, you have to define what column you want to update, and then you define what is that condition that you want to use it to update it. So that's how the update.
This is the first time we are using set in PROC SQL, right?
Correct. Yeah. So this set statement has nothing to do with the data set statement. This is different and this is different. This is to set the variable values, and this set statement is basically to specify the data set name from which you want to create a data set. Here, it is all about the column that you want to specify. Okay, so yeah, it gets complicated, so that's why we have to be a little careful. So this set statement in SQL is different. It is to update the column values in SQL, not in SAS, right? Again, so that's why you just listen to it and forget about it. Okay, so once you are thorough with it, then you can revisit these concepts. So yeah, this is the modify statement. Modify how it works in SAS, and this is how it works in SQL. Okay, so the same way people tend to write it this way too. This is one of the condition. Okay, let's assume I have a data set, input, ID, and gender. So I have 1, 2, 3 gender, M, 1, 2, 4 female. Now, what I want to do is, whenever M is there, so this data set, just imagine it was created like 1 year ago. Now somebody came back and said, whenever there is a gender M, I want to update it to MALE. Whenever there is a gender F, I want to update it to female. Okay, so how you're going to do it? So in data step, again, you can use modify statement. You can go modify X. So you can say, sorry, gender, right? Gender male, then gender is equal to gender is equal to female. Sorry, so I'm just using if else condition. Now run it. Okay, so now this is what we have in X data set right now. If I just go and update it, okay, just look at it. So it must have updated the observations. Now if you go here, it must have been updated. So this thing has to be done with update statement, this update and set statement in SQL. So PROC SQL, first you write the table name, update X. Let me just recreate the data set so that now I have X data set. Okay, now update X, set. So I'm setting the column that I want to update. Then here I use the condition. Okay, so the if and else condition, case when gender is equal to male, then so again you have to compare it and learn it, right? So the syntax you have to remember. Gender is equal to female. So that's it. Okay, you do not have to write end as gender. You can just write this way, okay, end, because you are updating the table. You do not have to write end as. Okay, now just run it. And what happened? Okay, it's not taking. Case when gender is equal to male, then male gender. So that's the mistake. I again see this is the confusion. So I instead of specifying the condition, I just specified the gender is equal. Okay, in SQL it doesn't. See, this is updated. So yeah, so this is how conditionally, if you want to update a table or modify a table in data step or SAS, this is how it works in SQL. These kind of cases, okay, case when. So again, it'll always takes time to get used to if you are especially coming from here. So here in data step, we specify the variable values. Okay, we use an assignment statement and then we write condition. Here first you write the condition, then at the end you define the variable name. So here I'm not writing end as gender because it is already defined. Okay, I'm not creating it, I'm just updating. So it always ends with an end. So here set statement, I'm specifying the variable, then I'm specifying the condition that I want it, right? So this is the update statement between data step and the SQL. Okay, the same way. Now another question for you. I have a data set called X. I have a data set called set SAS.class. When you say dependency, right? When you say dependency.
No. I'm not saying dependency. Tony has asked why we need to select distinct IDs or ID. It depends, right? That's for that I'm answering. It depends, right? I'm saying.
Oh, okay, sorry. I mean, I will ask that previous shot, right? Okay. So, okay. Now I have this, okay, Alfred and Jane in this, okay, X data set, okay. Now I want to filter these values, PROC SQL, create table, select. So I want to select those names, okay. I just want these names to be filtered from it, okay. So again, same condition, but how do we do it for name variable, okay. So you write where name in. So again, these are some of the pitfalls, okay, because a lot of people, and again, select name from X data set, okay. So what is the problem you see here? So a lot of people gets confused, okay, especially when writing subqueries. I've seen a lot of people go back. Okay, I wrote it, but it always returns 0 records, 0 rows. Okay. Oops. See, now the 0 records. So how would you debug this one, right? So if this happens to you, now I know that Alfred and Jane both are available in this data set, but it doesn't work. Okay, it returns 0 records. What would you do? How do you debug this one? Because this could be a tricky one. How do you debug this? So the query looks good. There are no errors in the query. And you see the data here, but it returns 0 records.
I mean, it's from SAS help.class, right? Not from X.
No. X data set is this one. my subquery one, my inner query one, and I'm filtering the data from SAS class.
So what the names are case sensitive here?
Yes. Yeah. So that's what I need to check, because when you write these kind of queries, right? Because again, generally, if you are writing filter, you would always know if I specify Alfred and if I hard code them, I'll definitely know, okay, what are the cases, but I'm using another data set reference. So there are chances that you might not be aware of them. Okay. So you need to make sure you are these, whatever you have in this data set are matching with this case. Okay. So that's when a little trick would be convert either uppercase or lowercase and mention this one. Okay. So that it is more dynamic coding. Okay. So again, if you see here, now it has 2 records. So let's go to Y. See now, because it is in prop case. The first letter is in uppercase and the rest of the letter is in lower case. Yep. Okay. So yeah. So this is something, again, I have seen a lot of people, especially first timers. Okay. When you write subqueries, we tend to ignore the cases. Okay. You write and everything. There is no syntax error. You go back and forth and you always end up, of course, you would understand that these are the cases once you see 0 records, but this is a best practice, okay? Because when you write uppercase, when you write any function on this, you're not changing any output, right? So if you look at here, the output remains same. Only thing is your query, you are just adding a functionality to work it efficiently without having to specify. Even tomorrow, if the case change, if tomorrow the case changes in this, okay, and this will still be able to pick it up, right? Because everything gets converted. When it's converted and it matches with this, okay? So yeah, this is something I wanted to show you, okay? So again, now likewise, we have a lot of them, okay? So again, this is another query for you, okay? You guys have to answer it, okay? So let's assume I have a department and we have salary. So I have it this way, okay? Let me add more. Okay, so I have it this way. Now my query is filter those departments whose average salary, department's average salary is greater than entire company's average salary. Okay, so I mean, this is again to put it in context. Okay, so how the subqueries will help you in this kind of case. Okay, so now the question is, filter those departments whose average salary is greater than entire company's average salary. There are 2 ways to do it. Again, one with subquery, and we can do it straight to using SQL, whatever that we discussed so far. Okay, think of a logic. Now filter those departments whose average salary is greater than entire company's average salary. Let's say you have 3 departments here: HR, finance, and analyst. So your requirement is you want to find out which department's average salary is greater than the entire company's average salary. Okay, so how do you break it?
One, get the sum for our entire group, and then otherwise you can do a distinct for each department and then get the sum. I mean the average.
Okay, first let's get the average salary for the entire department. So PROC SQL. And remember, you do not have to always write create table. Okay, you can write select directly and it will print your output into log window. Just like PROC print, you can directly print it into log window. Salary, let's say I'm gonna write total salary from X. Okay, so this is your entire company's, right? Entire company's average salary. So this you can do. So just go run it. So it says you are not specifying any group by or anything. So you are just applying mean of salary as total salary. Remember, the mean function will calculate the column wise, right? Now you would get the entire average salary of the company. So which is 8292. 8292. Again, if you want to round it, you can always go round it to the nearest integer value. So 8293. Now what do? You found out in one step. Now what was your requirement? Now filter those departments whose average salary is greater than entire company's average salary. Now we know that entire company's average salary is
8 to something, yeah.
8293, right? So what do? Here you go, PROC SQL. Again, you do not have to write create table all the time. Select. So first let's find out department and mean of salary as, I'm gonna call it department salary from X group by department. Okay, so first let's run this one and find out. So I'm just grouping it by department. If you see analyst 8725, finance 8100, HR 8140. So now, so this is just creating a query. Okay, you're just finding out the department wise average salary. So analyst department is 8725, finance has 8100, and this one has 8140. Now you have to filter this one where it is greater than. So probably you go right having department salary greater than 8293. Okay, now let's just run it. So you have only one department whose salary is great, whose average salary is greater than the entire company's. Okay, so this one works. Okay, this one works. Now your requirement, this is fine, but again, this is not efficient because if you ask me, let's say tomorrow more departments are added. Okay, let's say operation team is added.
Instead of number, you can add the select query, right?
Yes. So that's what we're trying to get. Okay, so this way you can do it, but the problem is now writing this way, it's not efficient because see, now you wrote it now 8,900, right? So the department is added. Okay, now you still have 8,293, but let's look at if it has changed. See, now it is 7512, but you're still using 8293 inquiry. So you cannot go and change it today. Again, another 3 more departments are added tomorrow. Again, you cannot go back and change it. So that's when, instead of writing it this way, so the entire thing would remain same. All you have to do is this one, you can just replace it with select mean of salary from the X data set. Okay. So again, you can, so now run it. See, so all departments are greater than now the entire company's average salary. Now it has, the query has become dynamic. Okay, so whenever, even if you add 1,000 departments, it will be able to get the entire company's average salary and filter out for on that day who's, I mean, what are the departments that have more salary compared to the average salary of the company. Okay, so this is one example of a subquery. And Another thing you have to remember, in subquery or in inner query, only one column can be specified. Only one column can be specified. So, and remember, the result is written always from the outer query. The result is written. So no matter what you do in the subqueries, the result is always written from the outer query, but inner query is just your, by this time you must have understood, it is just a filter condition on this table. Okay, now let's see what happens. Okay, this again I have observed a lot of time. Okay, people come back to me and say the subquery isn't working because the subquery, the inner query accepts. So for example, I have the same thing. Now just imagine, put select asterisk. So the moment you put asterisk here, what does it mean? Is you want to select all the columns. Okay, let's just see what's going to happen. See now, this is what the error will get. So if you are trying to specify more than one column in the subquery, it is going to say that a subquery cannot select more than one column. Okay, so you have to make sure you are using, because your output expects you to return. Okay, the subquery definition itself, the subquery, the inner query will have one column and the output is extracted from the outer query. All right, so this is a non-correlated subquery. And again, remember, I'm just giving you only one outer query and one inner query. Okay, so again, you can write multiple queries to here. So again, if you have another table where the data is coming to that X data set from where, let's say, name in, you can go right, select name. Let's say you have another table, select name from, likewise. Okay, so you can write a number of queries. Okay, for our convenience, I'm just giving you one. There's no, again, rule that you should have only one inner query and one outer query. You can have multiple inner queries and one outer query. All right, now, so these are non-correlated, okay, because whenever this gets executed, it really doesn't expect anything from this output. Okay, this can get executed without any relation with this table. Okay, but however, the outer query depends on this one, but not the inner query. Inner query doesn't, the subquery doesn't get isn't dependent on this one. So that's why it is a non-correlated subquery. Okay, so let's look at a correlated subquery and see how we get it. Okay, so the correlated subquery, the best example would be, again, you can think of a logic. So I have, let's say, ID, age, 3, 27, 124, 28, 125, 6, 30. Data set, data Y, put ID, location. 3, LA, 124, 6. Now, again, my requirement is from this data set, I just want to filter this data set. Who are this customer? How many customers? Okay, whoever the customers are from location LA. I want only ID, age, and column. I want to return those values from LA and CA. So in this case, if you see 1, 2, 3 and 1, 2, 5 are from LA. So I just want these 3 records to be filtered on the X data set. So how would you do it? Forget about subquery thinking. Think of it in general with whatever the knowledge you have.
Sorry, what do you need from the X?
From the X data set, I want those IDs that are from location LA.
Inner merge?
Yeah, inner merge works. Anything else? Anything else? Think of it in non-correlated subquery non-correlated subquery way.
If you simply merge and then you have having location equals LA
Right.
on the Y data set.
Right. Yeah, that'll work too. The merge, it'll work. Yeah, so you figured it out, right? So now we can do the same thing using a subquery select. So star from X data set. Oops. X data set where, so you define the condition here. Okay, so you see from the X data set you do not have location. Okay, so you want the location LA to be filtered. Okay, so you write select location from the X data set. So now what's going to happen here? You first run this one. Oh, sorry, this has to be one. And now, oops, what happened? See, this is a problem. Okay, so you are trying to filter only location LA. You said where LA is equal to select location from Y data set. Now you have multiple values here, right? There is no restriction for this. Okay, so everything works here. Okay, now don't you think I can write where X dot ID is equal to Y dot ID? Because when this has to get executed, okay, and it has to filter all those values. See now 1, 2, 3 and 1 to 7, right? So if you do not specify this one, now what's going to happen? Now the location, it prints everything. Okay, so all the LA, CAs, LY, NY and everything gets printed. So it goes like where LA is equal to, and you have multiple locations filtered. So that's why it don't work. Okay, it doesn't work. Again, remember in the subquery, you are not defining the variable name here. So you are just reversing it. Okay, where LA is from this particular query. Now when I run it, this is going to cause an error. Subquery evaluated more than one row because you are filtering everything. So that's when you have to say that I want IDs to be matched and then rows to be written. Okay, now when you run this one, now 1 to 3 and 1 to 5 both are written. Okay, so that is what we wanted, right? So 1 to 3 and 1 to 5 both have been written. Now this is called a correlated subquery. Now the reason this is called correlated subquery, so remember always inner query gets executed. Whenever inner query gets executed first, the inner query looks at, so it goes here, it goes, okay, X dot ID is equal to Y dot ID set. So when it gets executed, does it know that X value is here? No, right? In this query, it doesn't know that what is this X data set. So what it does is it goes to the outer query and understand what is this X table and comes back here. So now if you look here, this inner query is actually dependent on outer query execution. So in order to execute inner query first, SAS has to go and execute the outer query first and then come back to the inner query. So hence the name is correlated subquery. So first, the inner query gets executed. The moment it sees the reference of X data set, then it has to go and execute this. And come until this particular query and then come back and execute this one. Okay, so this is known as a correlated subquery. Okay, so yeah,
basically it has to connect both the data sets, right?
Correct.
Okay.
Yeah, so it has to collect both the data sets information. So that's why this inner query is actually dependent on this query. I mean, if it gets executed, then it'll understand that x dot id is coming from this data set, and by this time this statement comes here, it knows that the x data set has to be executed and then come here. All right.
Can we do 3 or 4 there?
Sorry.
Can we do 3 or 4 data sets in the subquery?
Yes, you can. You can do a number of data sets. So only thing, so you can go right if you feel that there's another one that is coming from, and let's say there is another data set you have that is coming from another data set called Z data set. You can write it this way. See, but again, in this case, again, if you see here, the Z data set is this inner query doesn't have, it's not a correlated one, it's just non-correlated one. And this becomes your correlated subquery. And again, this will become your outer query. And remember, the output is always written from this one. Output is always written from this particular query, the outer query. Okay, so yeah, so pretty much anything that you do here, again, if you have to draw it parallelly, anything can be done with join also. Okay, but again, you don't want to do the join all the time. Okay, especially just imagine you have in this case, right, where you wanted to only filter 2 values. Okay, you know that every day you are going to have only 2 values, and these 2 values will change. So that's why you are using the subquery. But just imagine you use a join here to join this and say that, okay, well, even in order to do inner join, right? Just imagine you have 100 million records in one table, this table, and 100 millions in this table. Okay, do you think performing a join on such cases just to filter 2 values here, because every day it is going to be 2 values, to just filter 2 values, joining more than 100 million records, do you think it is optimal? No, right? So yeah, so yeah, that's where the subquery is more useful. All right. Any questions on this?
No.
Okay, sorry. Okay, a small. Okay, a small. Okay, before we move, right? I just want to test your knowledge on how far you guys are with SQL. So we have this way. Okay, so we have this way. So the ID data set. So now let's say filter if the average, sorry, if the sum, filter if the total salary greater than 25, sorry, the total salary is greater than 200,000. So write me your query and show me, because there's a reason I'm asking this question. So I just want to understand if you can write it. So again, I want to filter if Not let me not put it this way. I want to return all these records. Okay, I want to filter only this data set. If the entire salary is greater than 20,000. So let's assume I just want to go write PROC SQL, create table one as select star from X. So this will return everything, right? This will return everything. Now I want to create this data set. Now, if you go to new one, I have this. Okay, my requirement is if the sum of the entire salary is greater than 200,000, then only I want to return it, or else the record should be 0. How do you filter it?
Wait, what's the query being requested again?
Sorry, Tony?
So what's the request? What exactly are we asking to do?
So now I filtered it. Right? So now I have. No, I'm not filtering it. Okay, I just created this data set called new one. The new one data set is created. Now I want this data set to be created only if total salary greater than 200,000. So I need to add a condition here. I need to add a filter condition saying if the total salary is greater than 200,000, or else this should, if this entire salary, right, the sum of salary is not less than 200,000, this should not have any records. I just want to add a filter condition that only if it is greater than 20,000, I should have output, or else it should have 0 records here.
You know, total sum, right? And then having condition that's more than
20,000. Yeah, just write this down. Just write this down.
Oh,
yeah. I know it's simple query, but yeah, I just want to make sure. Because if you are able to write this, probably you would understand how does the sum function work there. So, and you would remember it for forever. Perfect. Thank you, Tony. Yep, that works. Okay. I thought, okay. Let's see. So your query is almost correct. Okay, you can run this, and I'm pinging you the data. Run this against everybody needs, right? Everybody, I'm giving you the data, so you can just run it. Everybody's figuring it out. Okay. So this is one way you can go, right, where sum of salary greater than. So I can just directly use this one. You're saying okay, now see what happened. Summary functions are restricted to the select and having classes only. So what does it mean is select star comma sum of salary as total salary. Okay, so I can go use having total salary greater than this one. Okay, now if you see here, it has 0 records. Okay, so which is what we wanted, right? So I use the function here. I use the function here to calculate the total sum, and then I added having and filtering it. Okay, So this will basically select everything from this data set, and as long as if this condition doesn't met, it's going to produce 0 records. Okay. Now, so we have something called calculated. So calculated. So again, so what does it mean is basically you want to use this, refer this column, so which is just calculated here. Okay, the total salary just calculated. So you can just put having calculated total salary greater than. So let's just see again if I use where here. Okay. So the where function doesn't really use the summary functions. Okay, so again you can write having total, or you can just put having. So calculated total sum, total salary greater than. So again, don't get confused. So people tend to write calculated in their condition. So calculated is nothing but, so in the same query, if this particular variable is created in the same query, so people write calculated. So you want to use that particular value there. So you understood right here. The reason I wanted you to write this one, you need to understand that while creating a data set, you can always, so let's just imagine you remove this. You need to, this is how you have to practice. Okay, if I write this way, what is going to happen? Okay, now the entire data from the X data set will be taken. At the same time, you'll have a sum function that is calculating the total salary. Okay, so if I just go here and run. Okay, so how to write SQL queries? So everything remains same. Okay. What? So have you guys noticed the moment you change from the Microsoft Edge, let's say it's a by default browser, right, in all the Windows systems. The moment you change the default one to Google Chrome, I see the system has drastically got even if I try to open Google Chrome, it always slows down. Do you guys observe that?
I don't use Chrome.
Okay. I don't know if it has something to do with it. I'm hoping Microsoft won't do that, unethical practice. But every time I try to open Google Chrome, it's a lot slower.
Maybe you can delete your temp files, right? Did you do that?
Yeah, I did. I tried everything.
You check your internet speed.
So what temp files you deleted? Like from how you deleted your templates?
You mean from the Google Drive?
No, from your CP, I'm saying, from your PC.
Oh yeah, so no, I mean, I don't have to, I mean, I have enough one. Okay, this is a new one, basically. I mean, it's an actually old one. I
Okay.
what do you call, I reinstalled everything, I deleted.
Okay, so let's do one thing. Can you click Windows R and just use a command called %.
Sorry?
Click on Windows R, Windows icon and R. So to just open your command prompt.
Oh, okay.
Yeah, so there you click on %temp%. Okay, so you can delete all this stuff. This is like junk for your stuff.
Okay, but these are just KBs, right?
Yes, that's fine. But sometimes what happens, your web browser still has your cache memory in place. So those also will be recorded here, Okay, so you can delete all this stuff, in a way to enhance your performance also.
Okay, let's see.
You can just do this for all current items and just.
Yeah, we'll just try this. Let's just see now.
But what I noticed with Google Chrome is I don't know whether it happened to everyone, but most of the people are experiencing this issue. So my Google Chrome got updated first. I don't know how the update has happened. I lost all my bookmarks. From last 10 years, what I have my bookmarks were gone. So again, I had some kind of workaround to get the bookmarks, but yeah, that's what is happening with, I don't know, automated updates. So make sure you switch off your automated updates for any other Windows thing, That's happening with Chrome.
Yeah, I have another laptop, so that totally works fine. The problem with this one, it's
no, I'm saying it's not nothing to do with your laptop, but it's more like with only the application I'm talking about, Chrome. So you see, my Mac has no issues, right? So my Windows, I have 2 or 3 laptops, but the point here is more like with the application I'm saying, nothing to do with your system.
No, not the system. I mean, because I use this one, right? Okay, so everybody is comfortable with this one, right? I mean, we all learn that. Okay, so again, to just show you one demonstration, right? How to develop the codes in SQL now. I mean, how to use this document now entirely. So one thing you can do is, so again, you go write proc import, first import the file. So based on the interactions, right? So okay, so out again. In this case, I'm just showing XYZ. You can just follow the document. Complete. So what's the requirement there? Transactions, right? So can you tell me what is that sheet name? Or let me open it. Transactions. This has to be range.
Transcation. It's not transactions you kept. It's only no.
This one, right?
Yeah. That's what I've seen. Can you remove the yes?
Yeah. That. Okay.
Dollar,
Yeah. The reason I kept that, intentionally is because initially when I started giving out this project, so people used to just memorize the transaction and type it. So, but again, that's always a bad thing, okay? Because if you keep doing that, especially when you get an error, it will be very difficult because you assume that that is the right spelling, and in real time you don't expect people to memorize and do it. So these kind of things have to happen properly. Slow today. Okay, so next move on to the next one. So we imported the file, transaction file, and so again, the importing part, right? The importing part happens as it is, okay? So you do not have to do anything. So we don't have anything in SQL. So you can just use this particular from SAS again as it is, okay? The same way. Now the second one is rules, import rule sheet. So these two you can do it as it is. You do not have to. Again, there is no use of SQL here, right? You can just import it to here. Now the transaction device, both are imported. Okay, so starting from the third point, okay, so you can start writing if customer ID first digits are equal to the first digits of type column in transactional device, then filter those only IDs into one data set and name it exact labels. Okay, so here you're going to write PROC SQL. So you have to be very careful. Okay, again, when you compare with SAS, it might work, but you're going to say case when, or you can select everything first, transactional device, where, so go to the document, it says, if customer ID first digits are equal to the first digits of type column in transactional device data set. Okay, so this again we remember, right? This is equal to the first digits of this. So you're going to write where, again, check the type. Okay, this is something again I know you did the same thing when you lend base SAS. Okay, so this has to be the numeric one. So if you are comparing this one, so where cust ID is equal to substr of n of type 1, 3. Okay, so let's run it. So that's what the document says, right? Oh. Yeah, this expected this today. Yeah, these files are gone, right? This one is fine. conduct technical support. Right access violation exception or okay.
Is it transaction underscore database only?
Transaction? No, that's the same one. If the table isn't available, I'm guessing this one.
Can you open the table? Okay.
Custom ID.
Transaction. So basically the transaction something, right? Again, the spelling.
No, I just copied and pasted it. That's fine.
No, the table which was created is transactionally. Okay.
No, I just copied and pasted it here. Let me check.
See, the type should be in inverted quotes.
No, it's not. Exceptional season. Yeah. Back, open a new session and do it. Just see. The same error. I'm not violating any right access violation. Why? Because I'm not violating anything. Okay. It's weird because it says I'm not violating anything, because if I go to work library, do I have any files with that? Yeah, because it isn't.
Can you drop those tables?
Even I created a fresh one, so I'm guessing this has to do with, because the same SQL query is working. So what I'm guessing now, because we are reading it from a file that is stored in the temporary location. Let me look at this one. So what I can do is,
So it's not able to access that file you need to see. But we imported into SAS, right?
Yeah, the work library. Okay, let me check. Okay, 9.44.
Or else can you create one library just for times, if that works?
Let's see what must have happened. Okay, this is the data set, right? So let me go here. Let's SAS temp files. Stored, this is stored. SAS temp. What is the problem? This to our exact.
Can you open that file once?
No, it's an empty data set. No, this one will have it because we saw that, right? The exact.
No, this is what something we imported, right? But is it opening the file?
The file gets open. There are no issues. If the file doesn't get created, this temporary file will not be visible. This every time you run, right? So this is something you can remember. Every time you create a data set in a library, it creates a temporary file and stores all this information here. See, you created 2 data sets and one PROC output you gave, right? So everything gets stored here. The moment you close the session, this get deleted. Okay, let me check one thing. Okay, if the configuration file isn't okay.
Is it happening with other sheets as well? Same, similarly?
This is the first time. I know it happens when we work in the institutes on the server, but not in my system at least, because nobody's trying to access my temp location.
Okay. So no, I'm saying with other sheets in the same system.
No. Okay, so yeah, I mean, again, I don't know how to resolve this because it it happens on servers because for servers, right, even in institute that I teach, it happens because we work on server. Everybody, let's say we have, at a time we allow 8 users to access it. Okay, so 8 users trying to create a huge amount of files, this error occurs because the space gets full on the temporary. But again,
I'm saying, can you just create a file name or a library and assign to that one, and we'll see like whether it's able to pick from there.
Yeah, that's a good idea, right? Lib name XYZD5. Let's say XYZ. Okay, save. Okay, problem. Let's create this one to XYZ. Creating in work, it shouldn't be a problem. XYZ transaction date.
Library is not assigned.
Does not exist. Why would it not exist?
So library you're giving after, right?
Oh, sorry.
Yeah.
Right. Let's run it. The same error.
Yeah.
Same error.
Something
wrong. Okay, I'll have to figure this out. Okay, anyhow, now you get the idea, right? PROC SQL. You write it so this way. Okay, so again, probably in data step you would have written this way. Transactional device, whatever you must have written if cust underscore id is equal to substr n of type comma 1 comma 3, and this should have produced the similar output. Okay, so this will do the same thing. Now when you go to the next one, now in the merging, right, so this is where it makes difference, right? So you do not have to sort the data set and merge it and whatever, right? So it will be a lot easier. Now merge newly created customer ID from exact labels dataset with merchant details by type. So type data set that we created from the rules data set, you can merge it. So yeah, so that's where you figure out how flexible SQL is, right? I mean, you do not, when compared to data step where you have to sort this both the data sets and perform the join. Okay, in SQL you'll find it a lot easier. Okay, so that's what I'm trying you guys to understand. So if you understand, that is fine, you can continue doing that. Okay, but for your references, you can keep the data step codes so that you'll understand how that is being done. Okay, just keep it side by side and start writing this code, so it will be a lot easier. All right. Okay, so in case, I mean, if I try to get it work, I'll show you guys tomorrow. Okay, again this one. Now we were supposed to talk about what? Subqueries, right? Yeah, subqueries. The subqueries are primarily two types. One is correlated, first non-correlated subquery, because this is an easy one, non-correlated subquery, and correlated subqueries. Okay, correlated subquery and non-correlated subquery. And so let's just see. Okay, so again, in order to learn this, right, again, if again you come from data step knowledge, okay, you might find it difficult initially, but let's just see how do we simplify this one. Okay, so that you'll easily understand. Okay, so just assume I have a data set, data set x, set SAS dot so sorry, data input ID age, I'm just going to give 1 to 3 27, 1 to 4 28, 1 to 5 29, data y, not data y. So let me create. So let's assume this is the file that you receive every day. Okay, and you get another requirement that says that that requirement is, so from the main table, so let's assume for this particular month you have this IDs and ages. Okay, now this is your master table. Let's assume every day you get, every day this data get generated. Okay, I'm just going to name it every day. Every day this data set is created. Now your requirement is, every day the requirement would be you might have to filter some certain employee IDs. Okay, certain employee IDs from every day. You basically are writing this way. Okay, let's assume today 1 to 3 1 to 4 is your requirement. So you have written this, it will work fine. You are trying to filter only 2 IDs here, so this will work fine totally. So if you go here, this is the main data set, and in the XYZ data set, you filtered it. Okay, now just imagine your client comes back to you and says, no, we do not want to specify every day, come back here and say that, okay, this is 1, 2, 3, 1, 2, 4. Tomorrow it might change to 1, 2, 5, 1, 2, 6, these IDs. And day after tomorrow, it will be again 1, 2, 3, 1, 2, 4, whatever, right? So every day these IDs will change. Now, instead of that, what that's telling you is, so we'll give you these details in a file. We'll just give you whatever the values you want here, whatever the values you want, the input values, because we don't want to every day go and change it here. Tomorrow it will be 124 and 126. I don't want you to change it. Okay. Instead of that, we'll send you an Excel file. That Excel file will have what IDs to be filtered. Okay. So which means in this case, just imagine this data has come from some Excel file. Now what they say that, so can you just use this data? Can you just use this IDs from this file instead of specifying it? Okay. So again, any ways you can think of it. So I just want to filter the IDs from this everyday data set that are already there in this data set, So any idea, anything you can think of?
Yeah, we create a temporary data set out of it and write select star from where clause. So you have a white data set, right, which has the IDs, and you have your master data set. So select star where, what you have given, right, where in?
Okay, that's subquery. I mean, prior to this, without subquery.
I mean left merge?
Left or inner?
Because you want this 123, 124, right?
Only inner will be working for, because you only want to see which have been matched.
Yeah,
right?
the inner merge, yeah.
Yeah, so inner merge will work. Okay, so we can go right. So Tony said it. The macros is another way, simpler way to do it. But again, as a concept, I still need to learn it here. Macros, again, when we learn macros, you'll find, okay, it's a lot easier. So I'm going to call it a dot star, comma, b dot star from. So I'm hoping everybody remember this every day as a, inner join, y, oops. Y as b and a dot id is equal to b dot id. So by doing this, right? So this is okay. Okay, this works fine totally.
But what I'm saying, we can use a where exists, right? Where exists from y.
Yes, we can, but we haven't talked about it yet, right? So yeah, you can use it. Oh, sorry. Okay, so now if you go here, it must have filtered only this ID and ages. Okay, so again, you are joining two tables here. Okay, so subquery will be pretty much a lot simpler compared to this. And again, when you go to macros, and macros will be even more easier. Okay, so here how the subquery works here. So here, this is your main query. You can call it an outer query. So which is being written the outside the braces. So here, you know that these IDs are coming from a data set called Y here, right? So what you can do is, instead of that, so basically you have to know that, okay, this is what you write. Basically, you want to filter this one and you are writing the IDs. So these IDs are coming from this one. So what you can do is you are going to replace this with the query select ID from Y. Now, what's going to happen here? The ID, when SAS goes and searches, okay, so the first, this is the outer query and this is known as inner query. Okay, remember the definitions because the definition, execution statement, order also you have to remember. Okay, so the outer query and the inner query. So the outer query, so always first remember inner query gets executed. Inner query gets executed first. Inner query gets executed first. So when it executes, so what it does is it selects the IDs from this table. Okay, so I mean, pretty much it'll just copy, it'll just print those values 1, 2, 3, and 1, 2, 4 here. Okay, so Now this gets executed first, the inner query. So you'll have whatever the values you have here. So literally it will be 1 to 3 and 1 to 4. Then the outer query gets executed. By the time the outer query gets executed, so it goes where ID in and 1 to 3 and 1 to 4. Okay, so just run this one. So if you see here, you'll have your 1 to 3 and 1 to 4. Okay, so this is a lot simpler comparing to the join, right? Because again, it has to, if you are joining them again, it has to search. It has to join both the tables and search for the information. So this is a lot easier. Okay, so this is known as a subquery, and especially this is known as a non-correlated subquery. The reason it is called non-correlated subquery is when the innermost query gets executed. When the innermost query gets executed, it doesn't have any dependency on the outer query. So if you see here, when this gets executed, you do not have any conditions that is depending on the first outer query. So that's why this is called non-correlated, because there is no correlation, there is no relationship between this one and this one. So these both get executed individually, right? Because you are not referring anything from this outer query, or you are not referring anything. It is just a filter condition. So that is why it is called a non-correlated subquery. Okay, so let's look at a couple of examples so that you understand it better. For example, I have another location. I have input ID location. So again, this you date it now using data step, right? Or let me just write name Alfred Jane. So let's just assume I have Alfred here, I have Jane here. Now in SAS help.class dataset, so I have that information, create table, new one, select. So yeah, so all you have to do is, okay, start writing the queries, use this base SAS tasks thing, this document to write, build and everything. Okay, so start it. Okay, so I know it might look confusing. Okay, once you start writing, you'd get one by one. Okay, trust me, I have seen this before. A lot of people get confused. Okay, where to start it, I don't know how to start it. Once you start it, everything will be clear. All right, so yeah, start this one. Okay, don't get worried. Okay, don't think, okay, I'll practice for some more and then let's start it. Okay, you start it, then eventually you'll get it. All right, any questions? Okay, so tomorrow we'll start macros, the macro programming. Again, you do not have to fear thinking, okay, I know, so some of you are still processing the SQL knowledge, because I know most of you are from non-programming background. So the macros, again, it's not going to do anything. Whatever you learn in SQL, data step, procedures, again, we are going to relearn them. So only thing we are going to do is, how do we apply these macros on these steps to reduce the programming and more of a, we call them dynamic programming. Okay, so dynamic programming is where you try to make sure your program works without specifying anything, without giving any inputs to run it. Okay, so this dynamic programming meaning of it's, you can call it some part of, right, automation. People call it automation. When I say automation, in terms of programming, okay, so you are writing something again and again. Every day you open the program and you write it. Every day you write the program and you close it and you open it again, you write it. Okay, so those kind of programmings are not recommended in real time. Okay, so they always say that, okay, just write dynamic programming. So the dynamic programming should work even if you are not there. Okay, even if you left the organization, okay, that should be working. So again, these macros, it might be a new concept to you people because you are still learning SAS entirely, but it'll all make sense to you after a certain point of time if you stick to SAS programming for a very long time. I mean, at least 1 year, 2 years, not just 1, 2 years. Okay, by the time you completely do all those projects that I'm going to give you, it'll make sense to you. Okay, why macros are useful, and what are you going to do with it, and what kind of situations these macros will help you. All right. So again, please remember, you're not going to learn anything new here in the macros too. It is just what you learned so far. That's all. All right. Yeah, if you don't have any questions, I'll see you guys tomorrow. But start doing those tasks, and yeah, you can share me. So unlike don't wait until the last task to be completed and share it. So if you do one task today, share it with me. If you do 2 tasks, share it with me. Don't wait until you finish those 13 tasks. Okay, if you are able to finish one today, just share it with me so I can take a look at it. Okay, because if everybody shares at the same time, it might be very difficult for me to evaluate. Right.
So what time it starts tomorrow, class?
Same time.
Okay.
Yeah, same time. I mean, 9 o'clock. I mean, the usual timing we had before last week.
Yeah. Okay.
Yeah.
6:10. Okay.
Yeah. Sure. Thank you so much. Yeah.
Thank you.
Bye bye.